Good morning, everyone. Hope everyone is having a great day. I guess it's evening for the majority of you, but bright and early for me. So today we're actually getting into R. So if everyone can see my screen, it's actually more complex than this. We're going to have you guys install R. We're going to kind of talk about the structure, how things operate, go through some conditional statements, go through loops, go through a break on this, on how to run an R script or batch script, and then we'll actually start getting into a little bit more of that in regards to vector scalars, things like that. And this, so this doesn't include everything we're going to cover because I'm going to go into a little more depth. As you can see, we have 3 sets of slides. We don't have to go through all of them today, but we'll go through the majority of those. So the biggest piece that we're going to first do, because the way that I want this to operate is you guys be able to fall along in tandem, is that we're going to install R and RStudio. So, this is where we ended yesterday, that R is available on Windows, Mac, and Linux. And there's essentially binaries for Windows and Mac. For Linux, there can be different things. So if you want to compile it yourself, you're more than able, or R and RStudio do have those distribution types, so you could uninstall through the package management. So what we're going to do, and I believe I posted these links yesterday as well, but I'll post these in here. Oh, actually, I think I can't copy and paste from this. Yeah. Okay, let's type it in. So the first one you need to install is cran.r-project.org, and then the other is an RStudio link. So RStudio download. Okay. And so if we go into this, you can also Google as well. You can Google CRAN R, and there's the Comprehensive R Archive Network. Generally speaking, one of these 6 should have what you need for downloading, but if you don't see what you need right there, we'll click this Comprehensive R Archive Network, and they should show up right here as well. So if you have Linux, Mac, or Windows, go ahead and click on your distribution. So this computer is using Windows 10. I'd go to download R for Windows. And you could just download the base. You don't need these other contribution type packages. And then it'll say right here, this download R 3.3.2 for Windows. It's nice now, R comes in 32 and 64-bit versions. Now it automatically includes both those versions, which is nice. So the thing is, if you use, if for some reason you didn't use RStudio and you were just using base R, there are 2 types of base R in there, and this may be too small for everyone to see, but if I go into R, there's this RI386 and RX64. So the i386 version, and it'll be a little bit different for Mac and Linux, but that version is for 32-bit, which means it'll only use a maximum of 4 gigabytes of RAM. The RX64 doesn't have those limitations. I think limitation 64 gigabytes, which nobody should have. And so there's a lot more processing power in that X64. So if you go to download, it'll download. It's about a 70 megabit file. I'm not sure how long that'll take for everyone. I'm going to try to just hang out for a bit, make sure everyone gets that installed. And as you guys are trying to download that, we'll also go to RStudio. You can Google that if you want as well. RStudio is the first one on there. There should be a download RStudio link as well. You can click that. It leads to the same link that I posted in chat. And then from there, depending on what OS version you have, whether you have Windows Vista 7, 8, or 10, if you have Mac, if you have one of these popular distributions like Ubuntu, Debian, or Fedora, and Red Hat, then you can click one of those. Otherwise, the source code is probably through this tarball, and then you could compile it yourself. So let's see, we have in my notes yesterday, we had 16 students. So what I'm going to give you guys do is take a little bit of time, and once you've installed R and are able to open it, and then also installed R Studio and able to open it, please let me know via chat, and I'm going to make tick marks next to your guys' names to make sure that everybody has R in R Studio before moving forward, because I don't want anyone to fall behind. If you have any questions in the meantime, just post it in chat. I will just be sitting here until we get everyone having R and R Studio installed. Okay. Usha, you have both those installed? Okay, perfect. R and R Studio. Okay. I'm gonna let's see. Both R Studio and console will be in different pages. Yeah. So the R itself you have to download first, and that's because it contains all the base functions and whatnot. And R Studio is just an IDE. It's a GUI that sits on top of R. You don't have to open both those every time you want to run analyses. You'll just open R Studio, but you need R in there to be able to process it. So the first one comes, R comes from that cran.r- project, and then R Studio comes from the other link, the products R Studio download. Okay, Rahul, got R and R Studio running. Let's see what you have. Okay. R Studio, great. Choose to run. Got both installed. And that's the cran R Manish. The other one didn't hyperlink. So, okay. That. Okay. Yeah, Vara Prasad, yes, install both those, please. Just a card, let's see where you on my sheet. Okay. Get on our studio. Okay. Let's see. Can we have both studio and console on a single page? Oops, I was supposed to get everybody. Okay. Can we get on our studio? Manish. Okay, Jatin. Jatin, were you here yesterday? Michelle. What do you mean by studio and console on the same page? And then Puneet, did you install R first, then R Studio, and then opened R Studio? Huh. I closed both of them down and reopened. It might just be that it had a few keys with the registry. Because R should do that, but R Studio shouldn't. And just an FYI, R can be a pain to try to search for on your desktop. So yeah, if you have this instead of R Studio open, I could see that happening. Okay, so who's here? Okay. Ajay Krishnan, have you had success with either of those yet? Okay. I appreciate it. Our studio. Okay. So let's see. Team's done, Jay's done. Graha. Manish, I'm not sure where you're at yet. Let's see, Puneet is done. Radhika is done. Chicharon, good. No, they don't reflect. So I could, in R, I could write X is assigned to 3, and then type X here, and it's 3. And then in R Studio, I could assign the variable X to 5, and if I ran that and then try to print X, it would be 5. So they're completely independent. They run in different environments. So you won't need R. I just want to make sure it opens for you. And you could do something like X arrow assignment 3, and that works. That way we know that all the functionality is working within R before moving on. Not able to see it at all, or it's too small? Hatches. Okay, let me stop sharing. I'm not sure why. Try this again. Okay, is that any better for everyone? Okay, 4% has 4. Working on our studio. That's great. Okay, what do you need help with? Good. Sravani, how are you doing? And then I believe Rahul is good. Yep, which is good. There's two issues now. Okay. Yeah, they are independent. Studio. I'm good. Thank you for asking. No, so a GUI in an IDE is something that rests on top of it. So it's like a visualization of the actual mechanics of a program. So if you think of R like, you know, something that can only run C+ or C# or something like that, versus you know, having Notepad or Eclipse IDE or any of those other ones that can handle processing various languages. That's essentially what RStudio does. It only works for R language, but so the R is the base that contains all the functionality we need, and the RStudio just makes things a lot easier to work with. Okay, so if we go to that link, yeah, Manisha, it should be it should automatically identify your OS, so you should be good there. Sorry guys, trying to get through everyone on here on our studio. Okay. Looks good. On our studio, Vishal. Okay. So we have a couple new faces. That's great. Okay. So we have. And then, okay. Let's see. Blah, blah, blah. Okay. Blah, blah. Okay. Thank you. Okay. Cancel. Done. J. Done. Okay. That's good. Let's see screen. I'm good, Shabani. Thanks for asking. No, you'll end up generally. I mean, you can even, you know, technically speaking, you could work from the command line interface for R, but you kind of just choose. I mean, there are other IDEs for R. Like if I Googled it. So Python's famous for having a lot of IDEs. I know Rodeo is one of them as well. Eclipse can do it. So if you worked with either of those, we'll look at CoraPost. Apparently there's other ones as well, like RedR, Rattle, blah, blah, blah. So all these do the same thing that RStudio does, but in different ways. It may have different functionality from RStudio, but all of them run on base R. You just generally don't have to open base R because it's not as useful. Hey, Vara, yeah. Let's get that out of the way. So yeah, you'll want to choose one of these first installers unless you decide not to work directly from the installer. You can do a zip tarball or compile your own source file. But yeah, this is the easiest, is just clicking whichever OS you have here, which is good for Practice Studio or Console. We can't install it without R. We need both for it to work. You can have R without RStudio, which you can't have the other way around. Okay, R has both. Great. Okay. Hopefully y'all can hear me now. I'm not sure why WebEx is having a couple issues. Yeah, 3.3.2. That version's fine. There's not too many differences between these. I mean, mine might not even be there. I can check though. Let's see. My R Studio, yeah, it's a couple versions behind, and my R version 3.2.1. So yeah, you know, mine are slightly further behind, but it tends to not be an issue because, but yeah, that's the best version to get. Okay, so are we missing anyone? Okay. It doesn't have a, at least it hasn't in the past, had some sort of auto compiler for updating. R doesn't. So you can update packages, but R itself, you have to go back to the CRAN page to download the newest version. So as you can see, you know, mine's 3.2.1 for this R. And so I can end up doing the same thing. R Studio, the same. You can update your packages, and you can check for updates in the help file. So look, it says R Studio 1.0.44 is available, and I could download it, but I won't do that for this course, or not right now. Oh, yeah, I mean, R doesn't host like a repository like Git might in regards to source code. So, and you know, you can always, if you use Git or Subversion or something like that, you can always Google Git with R, and there's packages for it. There's DevTools package, and you can essentially do your assignments to load R Studio. I'm not going to walk everyone through this because it requires a lot of work on the initial front. So generally speaking, wherever you, minimize that, wherever your environment is saved is where these source files are saved. So if I go to save this, the R file went to save in my documents. And I could name this test 1, and it's saved there. So then if I actually went into, oops, if I went to my documents folder, if I could find it, then we have this test 1 here. If I wanted to, I could open with Notepad, and there it is right there. Yep. I was just going through that quick since it's not part of the curriculum itself. But yes, definitely can. Is everybody good to move on? Okay. If anyone's not, just please say something. Otherwise, move forward here. So if your R, we'll get into the repository in the library. Desktop shortcuts. Yeah, I mean, if you have Windows, you know, you can always just, if you didn't save it at onset, you know, you can always right click, and there used to be a way. Well, you can at least pin it to the taskbar. There should be a way to just, you should be able to just drag and drop it to your desktop, and it'll create a shortcut. I don't see a desktop shortcuts. Okay. Did I answer everybody's questions? Okay, I hope so. We'll move on. If you have any questions, please feel free. So we have this installed. Close chat for a couple minutes. You know, it's always recommended to update to the most recent version, but it's not going to kill you. And you know, packages are externally created, sometimes by our studio, but a lot of times it's just created by the community itself. And they have to go through a validation process with every R in our studio update to make sure they don't break. And so, you know, sometimes it's slightly better to be maybe one or two small versions behind, but generally speaking, you don't want to get far behind because they tend to not have legacy support. So if you have a version from a year or two ago, a lot of packages might not be supported. So you want to make sure, generally speaking, that you have the most recent version of the install. Again, because it doesn't automatically check for you, you'll have to go in and do that. Okay, so you've installed this exe file, you know, everything in there, all the defaults. Our console, you should see that RX64, as long as you have 4 or more gigabytes of RAM, it should have installed both versions. You can open it. You could type the number 3 or 10 or whatever and hit enter, and it should show that as the next line. It's basically an automatic print function. If all that worked for you, then we have our studio. And so it's a GUI, it's an IDE to help make things easier for you and to help you be more productive in the course. So in regards to it, you know, it's not a requirement. I won't be able to support some other IDE through the course if you have an issue, since we're only leveraging our studio. But, you know, if you prefer Eclipse or side views, JGR, whatever, you can have any of these in as well. The desktop version is the most common for our studio. I haven't really worked with the web browser version yet. It's a little bit newer, but there is that capability as well. In regards to our studio, this is what we'll spend our time in a decent chunk of today and throughout this course. So again, just as we talked about yesterday, we have 4 different panels. And so we have the source panel, which is basically kind of like a notepad script. It'll highlight things and automatically format things for you, which is really nice. And nothing in that runs, nothing in that gets deleted without your say-so, which is really nice. The console is basically the command line or terminal. So anything you do there is basically only in memory. As soon as you close that, it's gone. So if you want to quick test something to make sure it works, you can run it there. But ideally, anything that you're working in will be in the source panel. The environment will show you what data sets, what variables, etc. you have in here. So if something seems to be not working, that's one of those places that you might want to check. So if you create a variable X and assigned it some vector of numbers, and then you try to run the vector and it won't produce any results, you might want to go to this global environment and ensure that the variable X is still in here. And then again, this last piece, there's 5 tabs on here. I can go through it on my version as well. So on this R GUI, this full size, 5 types of things. There's the file system itself. So you can leverage this. I generally tend not to. Any of your visualizations will show up in here as plots. There's left and right arrows, so you'll be able to circle through them. You can zoom in. You can export as images or PDFs. And cool. Then we have the packages. So basically, any external functions, any external packages are generally 99% of the time hosted on the CRAN repository. R in our studio have built-in functionality in regards to the repository. There's 2 ways to access something. One may be that I want to, that's a search for if you have it. So one is through this install link, and you see it accesses the CRAN repository right here. it'll go to install to wherever my default library is, and that's where it hosts those packages. It'll install the dependencies that are associated with it. So there might be other packages or other functions in other packages that are needed to run what you're doing. So if I wanted to install a random forest package, it's right there, and I can click install. And then you can see it installs here. The other way is that install.packages, random forest, and then I could run this line of code. Both those will end up producing random forest on this list here. And then if you want to load it, and we're all going to do this in a couple minutes, you can do library random forest, these are case sensitive, and run this line, or you could just check this box and that'll also load the library. Basically, it's better to work from here, and that's because, you know, say you had 11 packages you need to load at startup every time. You don't want to come in here and go hand check every package. You just want to be able to run a line of code and have all of them load. The help file is a really cool feature. We're going to go into this in a few minutes as well. Basically, our documentation, all of it is online, but it's built into our studio, so you can access a lot of that documentation. And then viewer isn't used too much. Okay, questions? No packages right now, but I will let you know if there's specific packages you need to load. In regards to repositories, basically everything hosted on CRAN, so you don't have to go to 20 different sources to find a potential package that you might need. You just need to use the CRAN repository via one of these mechanisms that I showed you. The two shortcuts, you want to use the RStudio one, so it should look like this. The background will probably be white instead of black, but that's what you want to focus on. So once you've installed R, you don't ever have to open it again. You just need to open RStudio. Use of library. So library loads a package. You know, we could have just called it package.load, but they named the function library. So all this does here, I run that. Oops, not library, sorry. And you might get a warning message. It was built under version 3.3.2. So if you have an old version, like mine slightly is, there could be potential bug issues, and that's why you want to stay up to date. But now the random forest package is loaded. If I go over here, you can see it's checked as well. So now whatever functions are in random forest, and you can click through, now like get tree function would actually work if I, you know, produce some new attribute versus if I had done this before I loaded the library, the function wouldn't work. Suppose I want to use a function. How can I know which package has that function? Google's your best bet. Generally, you'll know the package and not the reverse. You might not necessarily know that combine is what you need to use, but yeah. So if we went, okay, so get tree is a function in here. We'll see if the help function works for external packages. So we're going to do this help search as well. But get tree was the function we saw. If we run that, yeah, it shows it here, and then it shows that the package name is random forest. So you can go about it that way. So Google's one way. You can search for get tree in R, and it should tell you random forest package, or you can directly type the question mark in front of the function, and it'll let you know what package it's a part of. So a package is the source files, and so that's essentially the installer, just like you installed R in RStudio. And when you double-clicked RStudio, that's basically your library. So library is just accessing those packages. So you can basically imagine that a package is a zip file, and so you can't use what's in it yet on the install.package, but on library, that's essentially unzipping and loading those files. Okay. Get tree you don't need to worry about. I was just giving an example. but it's to show this help functionality, and we're going to kind of go through all of this as well to let you guys play around a bit as we work through this. So don't worry about the get tree itself. This was all just an example to show you how it operates. Okay. So, a couple things to know. Not critically important now, but sometimes you might want to tweak these in the future. I rarely ever have. So R starts in the working directory, also called the workspace. I'll show you how to get that working directory and set a different one. If present, basically anything you have, you can attach. So instead of, for example, the install.packages and loading a bunch of packages and libraries, you can actually, it's a little bit quirky, but you can actually append libraries that are loaded directly to your R profile. So anytime you load it, those things will already be automatically loaded. You wouldn't have to rerun the install.package and library functions. You could just open R and it's basically becomes part of the base package. And our data, generally when you save RStudio files, it will allow you to save an R data file, which is kind of like a snapshot of what you've run and everything else. Okay, so everything are basically user-defined objects. Our worry is a little less about global and local type environments, so don't really get too honed in or worried about that. The only thing that tends to matter is that there are overrides. So if I assign the number 5 to X, well, somebody can, I'd love to see what you guys think would happen. So if I ran these 2 lines of code, and then I went to print X, you don't have to type print, just showing you. What would X show as? Okay, so yeah, if we just ran X at 5, print X, we have X equals 5. But if we ran everything, X equals 3, just like you guys said. And the reason for that is because it overwrites the assignment. So you need to make sure that you label things in a meaningful way, and that way you don't accidentally overwrite operators. The one thing you also can't do in R, which is a good thing for the most part, is you can't assign, some sort of string or numbers or anything to a function that already exists. So I couldn't call a function library. You better not let me. And try to run library equals 5 if it lets me. That's quirky. Let's see. Okay. Or it might. So essentially, generally speaking, it'll either not let you do this, or it'll really screw some things up later when you have things that are labeled the same as functions. So please, please, please don't ever do what I just did. And so, yeah, here's the point that you can see in the global environment. I have 3 things in here. We have something called color equals green, something called library equals 5, and something called X equals 3. You can actually clear objects from the workspace in this way. There's also going to be another way that is syntax driven. Okay. So let's have everyone do this. You don't have to actually tell me what your working directory is, but you want to type get WD, open and close paren, and it should automatically always include the close paren, close quotations, close anything you need in RStudio. That's one nice feature. But go ahead and run the get WD, open and close parentheses, to return your working directory. And just let me know if that works for you. Okay, good. That's at least 5 yeses. Feel comfortable moving forward. So if I did the same thing, get working directory, it'll show me that that file path is in C users mat documents. Well, let's say I wanted to change that working directory. You know, I have all my Excel or CSV files in my downloads folder, right? So, oops, not documents, downloads. Okay. Or if I had a file path it. Edit. All right. I forgot that Windows 10 doesn't file path anymore. So one of the weird things, if you are with R, if you're working in Windows, is you'll see these forward and backslashes. So what I was trying to show you with this downloads path, I guess I could go into something else in here. Okay, yeah, so downloads doesn't directly show the path. So if I type this here, you can see, I think this only applies to Windows. I don't think it's for Mac and Linux, but you'll see these slashes going in this direction. But as you can see, when we ran get working directory, they're forward slashes, not backslashes. So if you have this, you're more than welcome to copy and paste that in, but you're going to have to change all these slashes to forward slashes to make that your working directory. Okay, so the working directory is essentially where you're accessing files, and you can have multiple working directories. I generally don't recommend that as well. And so you want a folder system that is easy to access for that. Oh, God, I don't know. Internal. So we can Google that real quick and see. I haven't seen that error before. Perfect. Oh, that was the actual syntax you said. Okay. I thought that was your output. Yeah, so see, Sharon, you want get WD, but then open and close the parent. Does it clean up automatically once we close the session? It depends. So if I go to close RStudio right now, it will say the following files have unsaved changes. So do you want to save the following? So test1.r is what I labeled this, which is just essentially a text window, you know, the source code. So I can choose to save that and the revisions there. And then you have our data as well, which would save what's in the global environment, any plots that you made, anything that's in the console, anything that's here. So if you didn't want to do that, you could uncheck this. So it wouldn't save the working environment or the console. It would just save what's in this test file. And then if you uncheck that, it just wouldn't save anything. Okay, perfect. And yeah, I mean, I definitely, you know, if you guys are asking questions and able to help answer each other throughout this, that's fantastic because it means you're able to read code and assess it, which is an important feature. So, and it'll help the class go smoother as well. So yeah, please feel free to help one another throughout this. Our data is the snapshot. The working directory is where you would save something like your CSV files. So it'll actually happen next week that we start loading CSV files. So they are different though. Okay, so there is one other way. So that's the way I recommend the setting the working directory, because then you know it and you have it saved right up here. But the other should be in Tools, Global Options. And so here you can see that I actually had, if you aren't in a project and you don't define it, then my working directory is users, Matt, downloads, Coursera R, because I I ran a script to extract some stuff from Coursera. This tells you your R version. You can choose to have other functionalities in here as well, like restore previously open source documents at startup, restore the R data, ask or always or never save the workspace to R data on exit. Do you want them to save the history? Do you want there to be debugging? Yeah, generally. Traceback and an error inspector, this can be useful if you keep getting error issues. We don't get too much into debugging, and I'm not a superstar at debugging either, so it's not necessarily a requirement, but it can be useful because the tracebacks will let you go through different sequences of functions. And, you know, like I won't go through all of these as well, or I'll just go through briefly. But some things like this general code and editing, a lot of this automatically handles formatting for you, so you don't want to change too much in here. You can have things that show up like white space characters, indent guides, blah, blah, blah. If that helps you, let's see, we don't need to worry about that. You can do diagnosticing. Okay. If you want to change the appearance, you can see that I have, it looks like idle finger set, but you can choose any, you know, color combination combo that you want, as well as font size, font, etc. You can choose what is in each pane. So if in this environment history, you want to add some other tabs, so you want the plots to be there instead, you're more than welcome. So you can essentially restructure this any way that you want. The packages, that package pane, that's what you guys see here. Secure download, generally good. The rest is fine. SWeave I don't use. LaTeX you might use, but probably not. If you do want to create a spelling dictionary, you can. There's also, so yeah, if you want to connect a Git account or SVN, you can do that here. And that, if you Google like Git and R, that'll lead to that first link, which is a full walkthrough. And then if you do publish RStudio or Swirl, something like that, that's an option as well. Okay. So let's actually go back in here. Okay. So what are we going to do? Let's see. So let's use ggplot2. I'm going to try to make this bigger so you guys can see both things at the same time, right? So kind of want you guys to take, let's take like maybe 2 minutes for this slide. You can see there are 6 different functionalities here. And so ggplot2 is a library. It's a graphing library. It's really good. And so I kind of want you to play around with it for a second, right? So the help.start doesn't require anything, and that'll and you can click the number as well to highlight the line. It'll be different depending on what you have, but if you have Windows, it's Control-Enter to run that line. And if you see down here, I know it's smaller. This actually leads directly to the data analysis R manuals. So all of the R manuals, you can use that. Sometimes it's easier for that piece just to do it in Google. But if we want to do help.package, right? Well, let's see. Our package name is ggplot2. And you know, if you guys can type all this in to make sure it's working for you, that you feel comfortable and understand it, that would be really beneficial. So if I Control-Enter help ggplot2, oops. Let's see if it needs that. Unless I have to install the package. Okay, let's try to run. Interesting. No documentation. Okay. That's interesting since Hadley Wickham developed ggplot2 and he works for our studio. Let's see if we try the double question marks like they suggested. Okay. So it looks like ggplot2 has vignettes attached, multiple help pages. You can see these are all the package names, so it's caret, and then some sort of functionality that uses ggplot2. Here's the packages. Actually, ggplot2, there's autoplot, access secondary, ggplot2, blah, blah, blah. The single and the double question mark ends up being really, really useful in regards to being able to quickly look at packages. ggplot2 is weird since it's an external package. So if we tried this, let's see if we can try this with caret. All right, that's not going to work for any external packages. I will make a note of that. All right, so what I would suggest then is the question mark in front, or it's double question marks for packages and single question marks for functions. So you can do that. And then let's see, anything else? There's keyword searches as well. So if you want to find things that say like random forest, you can do help.search with random forest in there. This question mark help will end up working for most anything. So it'll give you actually, so just like a package would, it'll give you the function itself. You can choose the topic, and then there's all of these different parameters or filters you can include as well. It'll end up telling you, okay, well, you can have these functions within package. This is what libloc does. It looks at character vectors of directory names in R libraries. You can be verbose, so that could be true or false if the file name is reported, etc. And then there's a lot of base packages as well. So like if you wanted to just find out about, say we wanted to, since the base functionality is in here in R, we wanted to know how mean works here. Well, we could do that question mark mean, and it'll show us that mean is in the base package. It works here. That mean, you can choose the vector or matrix or whatever you're trying to calculate the mean of. You can see that trim is the fraction of observations to be trimmed from each end of X before the mean is computed. Generally, from a statistical standpoint, we don't do that, but if you did have really strong outliers, that's why trim could be used. NA.rm is do you decide to remove missing values before calculating? So there's a lot of functionality there. It's generally using this or searching within the repository itself. Okay, and then we've kind of gone through this work as well before, right? So the way that we handle libraries and packages. So, this is list available packages to load. Again, that number sign operator essentially shows us that we can comment that out. And then if we wanted to do this library, I'll probably have more than you all on this, can run that. And it'll show the packages in my library at C users, Mat, Documents, R, Windows Library 3.3. So all these are the packages that I have. And then the packages in the library program files are 3.3.1 library. These are the base packages that are part of R itself. So these are the ones that I have like installed at some point on top of that. If you want to load a package, so say I want to load, so let's have everyone do this. We'll do party. That's easy to type, right? So first we want to do install.packages. Actually, I should do it up here. Install.packages, so it's plural. And then we need to put that inside of quotations. and then it'll close those quotations, it'll close that parentheses for us. You can highlight that, run that. It'll say that it's installing those. You get a zip file, it'll check that for the sums, and then it'll download that binary. Okay, so that's installed. Great, right? Well, now if we want to load that library so we can access the functionality within it, we want to do library and then parentheses party. So we go ahead and run that. It looks like it's loading these other required packages. Party won't operate necessarily well without it. And I'll get this warning message, you shouldn't, that R was built under R version 3.3.2. So after this course, I'll obviously need to upgrade to that. And let's see, that's primarily what you'll use. If you want to look at the contents within the library itself, you can do library help and then the party package. And if we go ahead and run this, it's basically a lot from the CRAN repository, right? So all these are an easier, more accessible way to get there. It tells you what it is. It's a computational toolbox for recursive partitioning. The core of the package is seed tree, which is conditional inference trees, blah, 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 right? You don't have to know what the heck all this means. And then you have these dependencies here. That means it uses some functions of these other packages to work. So it might also import some other functions, which is perfectly fine. You don't have to really worry about that. And then you have the actual functions here, what they do. So if you're running a random forest versus a binary tree, you know exactly what function you need to type in to do that. And then you could always do a help file on any of these functions to see exactly the syntax that you need to be able to write the code correctly. Okay, how are we doing here? Difference between load and attach package. I mean, there is no attach, so there's no like attach function in regards to this. So that's basically, I mean, these basically both just load it. You can't just do an attach in R. For clearing screen, there is, I have to remember what the heck it is though. Let's try it. Control L. There you go. Look at these guys. Fantastic students. Okay. Cool. So I think we've gone through this a few times here in regards to installing packages, so I'm not going to go through this piece again. But, you know, essentially there's two ways to do it. One's just point and click through here. Actually, I guess there's technically three. One's the point and click on here on the install. One is up here in this top functionality. You can go to install packages, which leads to the exact same link. Or my recommendation is going ahead and putting it in here. Okay, so let's go ahead and do our first quiz. So go ahead and write your answer for which of the following statements is true about R. And this is just one correct answer. I'm 99% sure. So R is a proprietary general purpose language. R excels in statistical computation and graphic capabilities. R syntaxes are very similar to the assembly language, or R has no graphic user interface. Okay. Primarily have B's on here. Yeah, and that's basically what R is developed as, is a statistical tool with graphing capabilities. It's not an assembly or compiler language. It's just object-oriented. Okay, this is just rote memorization. What does CRAN stand for? Comprehensive R Network, Computational R Network, Comprehensive R Archive Network, Computational R Archive Network. All right, she's I think it's all C's. Okay. See how you guys did. Correct. Comprehensive R archive network. Okay. So which of the following is not an IDE for R? Well, I bet you guys can guess. RStudio, RGUI, TinR, or Dreamweaver. Okay. And I'm seeing up top, most of you guys know that Dreamweaver is primarily used for HTML and CSS. So yeah, RStudio is the pretty much de facto standard IDE, but if after the course you don't like using it, there are other IDE solutions. So there's, so like if you're a Java programmer, then you may already love Eclipse, and so since it has R support functionality, you can do that. Okay. So we went through this part pretty quick, but which commands could be used to browse and access all the help documents in R? Help.start, help, library, or install.packages help? I'm actually intrigued. You guys are finishing that response. I'll close this. If help.help actually does something. Huh, interesting. Well, it does lead somewhere. Help is the primary interface in the help systems. Oh, so it just leads to the help function. Okay. Yes, to your guys' point, I believe everyone. Oh, we actually had a few answers. Okay, cool. So we'll go through what the right one is and why. Okay. So help.start, that's the one that gets us to essentially the front page of all of the manuals, right? So start. And you can see it essentially links directly to this HTTP doc index for all of the R manuals, reference materials, etc. The help.help did not actually know that would run, but that functionality leads to the help utility itself documentation. So not really useful. We also have library, which is what we use to load a package. And then install.packages help, that's actually part of base R, so this should not do anything. Okay, so if we wanted to load and install a package in R, would we do load package? Would we do library package? Would we do install packages? Or would we just do library? So this isn't installing the package, but we're wanting to load a package that we've already installed. Okay. For the most part, B, might be an A or C in there. Yep, so the load functionality, we don't use that to load packages. Like I said, it would be a better naming schema, but when it was created, we used library. So install packages, since I saw a couple answers on that as well, this is to actually install it. So that's not incorrect. This is the framework that we use. But in regards to actually loading it, and that's what the question asked for, we use the library function and then the package name. Okay, so the summary here, R is a programming language developed as an alternative to the S language. S is pretty much defunct now. R is available for Windows, Mac, and Linux, which is really nice if you have different computers. R's primary purpose and invention was for statistical computation, and then we added really good visualizations on top of that. R does have a steeper learning curve at first, and then we're working with large data sets. You need to remember that you're limited to the actual amount of RAM you have on your computer. So if you have really large data sets, you're going to have to take some sort of partition of that, so sort of subsample of that to be effective. R can be downloaded from CRAN, and then RStudio is the IDE that would be downloaded from RStudio. RStudio, I'm generally going to recommend running on a desktop so we don't experience weird errors if they don't update their browser in a timely fashion, but they do have a built-in web browser just like Jupyter Notebook does for Python. So R stores whatever user-defined objects, variables, classes you put in the workspace by allowing the user to take a snapshot of that current workspace and reloading it into the next time R starts. So that's a nice piece if you save it that way. Every single R function has its own help page, which is great if you need to explore or you need to understand what syntax you need. I also will use Google or Stack Overflow if there are quirks. And then not all packages are loaded by default, right? And so that's why we may have to install packages for external libraries. And then we'll have to load those libraries using that function. Okay, that's done with that piece. Let's see, what time is it? 8:10. Let's come back in 5 minutes, and that'll give you time to play around for a second if you want to play around. And if you have any questions, you can go ahead and put those in chat, and I will answer those in 5 minutes. So I want to give you guys a couple minutes to ingest this material, and then we'll start moving on to this next section. Oops. This next section, here we go, which will get into the R operators, the arithmetic, relational, logical, and assignment operators, as well as conditional statements, loops, and scripts, and then some commonly used R functions. And then the last thing that we'll do to end the day, we'll kind of be getting into the actual structures of data that we have. So let's take 5 minutes now, and then we'll come back. Thanks, guys. All right, cool. In real time, what's the size of RAM we work on for R? So, you know, it kind of just depends because file sizes are all over the place. So it might only be, you know, 100, 200 megabytes, or I've had R crash on me before. And a lot of times I'll work on Hadoop or AWS ecosystems. And have our server or something like Spark or H2O on those, so that way I don't really have the RAM restrictions of an actual PC. You might want to save workspaces because that way it will, you know, load whatever packages you had loaded up, and you know, you don't have to rerun all of the code. So if you had ran something that took 2 days to run, that will still be saved in working memory instead of you having to recompute all of that. And then we'll get into saving files you can save in different ways. Okay. Anyone have any other questions? And is everybody here? That's 2. I want to get at least 3 more. Okay. Yep. So yeah, R itself, as well as, you know, the CSV files, as well as objects you create, like all that goes directly into memory. So none of it saves on the hard drive or anything like that. So that's why those memory limitations exist. Not objects in regards to how you define them in something like Java, but we have classes, so I guess slightly different. Yeah, no, I mean, basically almost everything gets loaded directly into memory, so that's why you have to be cognizant of how much space you're using and processes. A terrible example would be something, and I can show you a quick picture of what it looks like in theory. hierarchical clustering. So at an organization I was with, I guess any of these work, but at an organization I was with, I tried to run a hierarchical clustering model, and you don't need to know what that is right now. We'll get into it later in this course, but there's different clustering techniques. And so K-means clustering technique ran in like 3 minutes on a few million people. But hierarchical clustering gave me an error message, and it told me I needed 784 gigabytes of RAM to run. So yeah, part of it is the object storage, part of it is the file storage, and then part of it is the actual processes themselves. So there will end up being limitations you have to kind of work around. Let's wait till we get to classes themselves. They're not necessarily connected to functions in some meaningful way, because you can run a lot of different functions on different class types. But we'll get into the different classes and being able to specify those and look at those. Okay. So lesson 3. So we'll do 40-ish minutes and then take another quick break, and then we'll continue with the rest of this material. So in this section, we're going to explain the 4 types of R operators, go through different types of conditional statements in R. We're going to discuss the different types of loops we can do, and loops in R won't necessarily always be optimal. In next week's lesson, when we get into the apply functions, that's where R really stands out. They tend to be a lot faster, so we often use those instead of actual loops here. But we're going to go through in regards to the actual loops and how they work. We'll want to go through some of the commands to run in R script and batch script. You don't necessarily do this too often, but if you were working directly from the command line or terminal, then, or trying to run something on AWS, that R script would be useful. And then we'll go in through some of the commonly used R functions. So there's essentially 4 types of operators. We have the arithmetic, the relational, the logical, and the assignment. And we're going to go through all of these. So arithmetic, right? Very typical common operators. We have the plus sign for addition, minus sign for subtraction, the sign over the 8, the asterisk, the multiplication sign as for multiplication, / for division. If we have an exponent, we can bring that to whatever power we want. The modulus is in the remainder as well as the integer division. So if we go ahead, let me open RStudio over here. We'll zoom that in so you guys can do this as well. Scoot this over. So if we just wanted to do 3 + 5, and we're not worrying about assigning any variable types or classes or anything right now, we'd run that and we get 8, right? So the plus sign works. We could do 3 - 5. Go ahead and run that. -2, that works as well. We want to do 3 × 5. 15, perfect. 3 ÷ 5, 0.6, works as well. If we want to do 3 to the 5th power, we could run that. 243, I believe that's correct. 3, 9, 27, 81, yep. And then let's see, we could do 3% % 5. And that gives 3. And then this 3% divided by %5 should give us 2, 0. Oh, integer division. Okay. I think it has to be 5 divided by 3. Okay. Yeah. So this doesn't. This essentially rounds off kind of like the Python 2.7 does. Okay. Everyone good with those? Okay, perfect. Yeah, so one is remainder, and then one is the actual just number of times it's divisible by. Okay. Then we can also do other operators, right? So if we want to compare two different sets of values, right? So we have, yeah, I mean, you know, I could say as a data scientist that I've never once used that function, Vara. So, like, it's not always necessary that you memorize or completely fully understand like every single function we go through, because we're going to go through a lot, and you know, that's generally not something that I'll ever need as a data scientist. So, you know, take some of this with a grain of salt. It's more about that you guys understand this, and then if you really needed to be able to find it, that you could do that through the help files, through Stack Overflow, through Googling, asking your neighbors in the course. So that's the biggest premise here. But this is just to show the logical operators, how all this works. So if we say 3 is less than 5, that logical operator will tell us it's true. If we say 3 is greater than 5, it's going to tell us that we're false. If we say 3 is less than or equal to 5, what do you guys say it's going to show? What's the solution to line 40 going to show us? Okay, looks like it's a little bit half and half. So what we're saying is 3 is less than or equal to 5. So if that's true, it should print true. If it's false, then it would print false. 3 is less than or equal to 5, so it prints true. Now, and what does it say here if we do 3 is greater than or equal to 5? Okay, good. So I think you guys got the hang of this. You can also do equals. So there are two types of operators with equals. So if we do equals, equals tends to work at like a functional level, a higher level. So I don't think this will run. We'll see. Yeah. So because here it's seen as an assignment operator at this global environment, we can't say that we're assigning 5 to 3, right? So if we work with objects themselves, so something like scalars or within a vector, you have to use double equal sign. So we say 3 double equal sign 5, and now it's going to tell us that's false. If we try to say that 3 is not equal to 5, then that should register as true because they're not equal. Okay. So I think you guys have a good grasp on that. We'll move forward. Again, you know, stop me anytime if you have questions. Logical operators I rarely work with as well because I'm generally doing data cleaning and modeling. But there are the operators as well. So, you know, what's a good example? Actually, I think we're about to get into an example of these, how they work. But you can have logical operators. So the exclamation itself, just like here, is a not operator. So 3 is not equal to 5. But you can do this with words as well, right? So you could have like green is not equal to red. And it won't even be equal to green either, right? And all outputs y of vector form and value comes 1. So let's see. Best way of saying that. Does this get into? Nope, we don't have scalars in here. Okay. So the biggest reason why is because a vector, or we'll say a scalar is a single number, right? So 3 counts as a scalar. and or 5 or anything that you can think of. A single number, a single character string, whatever. That's a scalar, type as scalar. But a vector is a list, right? So we might say that 1 through 10 is a vector. I don't even know if I can run this or if I need to run the concatenate function. Okay, so this is a vector, right? 1 through 10. And if I just had 1, and I try to run that, it's just going to produce 1. Now, as you see here, it's the list element that's showing up here. And a scalar is basically a 1-by-1 matrix, right? It's a 1-by-1 vector. So that's why you end up seeing that 1 show up here, because of its positioning within it. Okay. So we also have other logical operators. We can do element-wise logical. So we could say, I feel like we get into this in a moment, but if we want to find out if things are similar and do some sort of compare contrast, we could say, orange or blue, just like here, and orange or red. And then it would prove true because orange is in both those. Sorry, I'm not true. You mean like here? Yeah, it's just because it's the list orientation. So if this was a list, like if I'm not going to do the whole thing, but for I, in N or something like that, if we wanted to go through and this was a list of 1 through 10 or something like that, then it would, the first one for something running like this is slightly off, so don't worry about it, but it would show the 1 as true because 3 is greater than 1, and then it would show 2 as true, then it would show 3 is false, 4 is false, 5, 10 through 10 is false. So it's essentially to show the list order or the list placement that it's at. So it's just a placement mechanism so that it's easier for you to find things. Okay, cool. So we have these and or operators, not used too frequently, but they can be used as well. In regards to assignment operators, it's always rule of thumb best to assign to the left. So you want the variable or feature, whatever you want to call it, name on the left side. We do the less than sign, dash, and then whatever the assignment is. And, it can be something like that. We'll get into what that actually means in a second. But, and then if we wanted to print age, we could see that age includes 18 through 50. And so, yeah, to the point, this would be the 26th row of that vector, starts at 43. So, yeah, you can do this right assignment, but it's not recommended. Okay, so then we're going to get into if-else statements. We can do regular if-else and nested if-else. They do have some strong functionality, but again, when we get into the apply functions, that's where it's going to be much stronger and useful. But in regards to how these work, so let's say we assign age, instead of 18 to 50, we say age is 20, right? Now, let's say we also have this syntax, right? If age is greater than 18, print major, else print minor. So if we ran all of this right now, what would the answer show? What would the output be? And feel free to type this as well, but yeah, I just want to see what you guys think the output is for this. Okay, major, major. I think it should be that, I believe. All right, if we run that, where those two match, those two match, those two match. Oh, I think I need one there and one there. What am I missing here, guys? Page print. Oh, I might not actually need that. Okay, yep. There we go. So we said if age is greater than 18, print major, else print minor. And so it runs through this first loop here, and it goes age. Okay, so age variable, well, age variable is 20. That plugs that in here. So if 20 is greater than 18, print major. Well, 20 is greater than 18, so it just stops. Now, if we had, let's say we did this, right? We say age is 10 through 20. It's a vector, right? And we can see that here if we print it, right? So it's a vector of ages 10 through 20. And then we ran this. Oh, that's right. We can't always do that for vectors. Okay. If else gets funky with vectors when you try to do that. I always get ahead of myself and forget. But essentially what it would do is, we're just going to use the apply function for this, but it would iterate through this, right? So it would plug in 10 first, so it says 10 is greater than 18, print major. Well, it's not, so it goes to the else statement, so it would print minor. So what it would do for the first 8, it would print minor, and then the last 2, it would print major. Yeah, so this is something R ends up having quirks every now and then as well. So you get this warning message, and if age greater than 18 condition is length greater than 1, meaning it's not a scalar, it's a vector, only the first element will be used, which means all it would use would be 10. Okay, so let's all go ahead and type this next one in. Before you run it, would love to know what you think the results are going to be. And I'm not going to interpret it out loud this time because I want you to try to figure that out. Make sure you understand the interpretation of these. So once you think you know what the answer is going to be on this, go ahead and type it in. Okay, we got most of the answers. Okay, so cool. So we assign x to 0, and then we go ahead and print this. And just like everybody said, you guys did a great job. 0 is the answer. And so again, loop statements work in the way where it will terminate once it reaches whatever the actual result is. So if x was -1, right? We ran that and then ran all this code again. It'll say negative number. And it should, we'll see if this works. Yep. So we could just run this statement here. If x is less than 0, print negative number, because the way that it's operating is solely based on sequential order. So it first checks if x is less than 0, print negative number. If it hits it, it's done. If not, it'll move to this next else if statement. So else if is like elif on Python. So we'd say, okay, well, x isn't negative. Let's see if x is positive. Then I can print positive number. Oh, x isn't positive either, else print 0. So great job, guys, on that. Okay. And then let's see. The if-else statement we kind of just went through. So the C function we'll get into in a second, but it's essentially concatenate or combine. So if we ran that first one, printed A, you can see it's now a vector of string or of integers 1, 2, 3, 4. Then if we went to run this if else, it should work. So if any of you have ever worked with Excel before, kind of the same premise on this line. Perfect. Okay. So if A is divisible by 2 leaves a remainder of 0, then it's even, otherwise it's odd, right? So it's checking 1 divisible by 2 has a remainder of 0. Well, no, it's not even because there's a remainder technically of -1. So it's odd. 2 divided by 2 has a remainder of 0, so it's even. So there's a lot of functionality that can be done in R compared to using multiple different softwares. Okay, so switch is one that I actually learned recently. I had never used it before, but it's actually pretty interesting, right? So we see it as a controlled branch of if-else statements. And so the second line will be more interesting for us all to run. You might just want to type that in. But this first line, you can see it essentially looks for the placement. And then we'll run essential if-else statements throughout this. So if we assign the color green, and this is an error right here, it needs to be green in quotation marks. So we assign green to the variable color. And technically we should do the arrow assignment, right? So we run this. We can print color, and we see that it's green. So then we go to switch function, and we go to color, which means technically this is the word green, right? And let's see if we can slide this over for you guys, give you a little more room. So we have switch color, and then it's going to give a few options. So what we're doing here is saying, okay, I guess I won't write all this out, but the way this is operating is it's saying, okay, well, take this variable, whether it's a scalar or a vector, and we're going to run this on these different functions. And so, okay, if the color is red, then we're going to print apple. If color here, this function, shows up as yellow, then we're going to print the word banana. Or especially else if, or else, color is green, then I'll print avocado. So based on this, what are you guys going to see printed? Perfect. You guys get it. Great minds. Okay. So yeah, it would print avocado because essentially it's just cycling through until it finds the one that works. Okay. So then we can do these for loops, which is kind of the most common. We can also do while loops, and then we can do repeating loops. So a for loop is done an explicit number of times, right? So if we go ahead and create a vector called vec, and then we concatenate 1, 2, 3, 4, and 5, or you can also do 1:5. And we run that, then we'll see that it prints vec 1 through 5, right? And this says for val in vec, print val. Now, this isn't really going to produce anything interesting for us because we already know what those values are. But if we had some sort of index attached to that, right? So instead of just the value, we asked it to, take the first 10 rows, but they all had names, it would print those names up. But essentially, the for loop iterates through however many are in whatever the for loop actually entails. So here, it would run 5 times because in vec, there are 5 numbers, 1, 2, 3, 4, and 5. Now, in a while loop, you can see, let's make this bigger for you. test expression remains true, the code inside the loop keeps on executing, right? So that means it does not stop unless you specify a stop, as long as the test expression remains true. So if we assign the letter I to a scalar of 1, then we say, while I is less than 6, print I, and then make I equal to I plus 1. So, do you guys have an idea of what's going to print out here? Awesome. Great job, guys. Yep. So essentially, you know, it would print 1 because I is normally 1 and it's less than 6. So then it prints 1. And then we say I equals 1 plus 1. Now it's 2. Then it cycles back through. While 2 is less than 6, print 2. And so until it hits 6, that's what's going to iterate. The thing you have to be careful of with while loops is that if there isn't some sort of hard stop, then it's going to keep looping forever. And if there is any sort of memory leak, then it'll end up crashing your RStudio system at some point. So you have to make sure you either put in a hard break or you know that it's only going to iterate a set amount of times, like in this case. So the other piece is that there's repeat loops. They can iterate code multiple times. And if there aren't the conditional checks to exit the loop, you have to specify inside the body of the loop, right? So here, it would be the same thing. So if we did a repeat as the for loop with x assigned to 1, it would print 1. And then it would say 1 plus 1 equals 2. And then if 2 is equal to 6, then break. Well, it's not equal to 6, so then it'll repeat back through. Print 2, 2 plus 1 equals 3. If 3 is equal to 6, nope. Okay, so we loop back through. And, you know, so if we didn't have this break in here, based on this code, do you guys know what you would see? Or I guess we should just say these first 3 lines, repeat, print, and x equals x plus 1. So if we ran this, what would you see? So yeah, great job, Vishal, Scott, and Puneet. Yeah, it would be infinite because every single time we're increasing that iteration plus 1. And so this would essentially keep running on your computer and essentially will, you know, every byte will increase that so that at some point it'll crash your R system. So you want to make sure that if there are potential for infinite loops, then yeah, that break's going to cause, that's why we need that break in there. So, you know, the same thing, just like I was just talking about, when inside that loop, those breaks actually stop the iteration from executing. So you can have hard breaks in there, or you can have if breaks in there. So Manish, it would go, so this is basically a for loop, right? The repeat function is a for loop. And so if we originally assigned x to 1, then we're saying, okay, print 1. And then we say 1 plus 1 equals 2. So now repeat that, print 2. 2 plus 1 equals 3. Repeat that, print 3. 3 plus 1 equals 4. So it's just going to keep iterating higher and higher because there is no limit. We're not talking about running this piece. This piece doesn't exist now. We were only talking about running these 3 lines. And because there's no parameter that specifies a stop point, like x equals 6, or x running 100 times, then it'll keep going. Yeah, I was talking about without running this. So this won't. This will just run 1 through 5. Or I'm sorry, 1 through 6. No, 1 through 5. So yeah, what you were talking about was correct with this line in here. Okay. So I think you guys get how breaks work. So next could be skipping current iterations of a loop. I don't think I've ever used the next function, so I probably wouldn't worry about it. But if you want to potentially skip a value or some function, then you could do that as well. Okay, full screen for a minute. So we'll go ahead and do this together. So there are, just open up a new script here. So there's going to be a number of different ways to read in data, and it depends on the file type, but R can read in most every file type, including things like SPSS or other legacy files. Oh, that's from the council. Yeah. Yeah, we're not going to read them from that directly. So if we want to specify something, and we can type this in here, http://www.ats.ucla.edu/stat/data/scan.text. And then I think Simplilearn put parameters in here as well. Since I've worked with this data set, we'll include those parameters. What equals list? I'm saying age equals 0, name equals, looks like double parent. So I'm not quite sure what this will run because I haven't worked with this data set before. But it looks like it just, the scan, essentially reads the number of rows and just gives you a count of the records. We're going to have other things like read.table, read.csv that'll actually be used for reading the files. But in regards to, say you had something with, 10 million records, you want to do the scan to make sure that R would, conceivably say, oh, okay, it looks like we have 10 million records here. Because if it only says that it read 500 records, then there's something wrong, likely with the data, because it hasn't been ingested or anything yet. It just does a quick scan of the number of rows. Okay. So we can also use source. So there is that like read.text as well. So you may end up using that. But when we're looking to run R scripts themselves, I can type this into chat. So that's typed into chat, but yeah, I ran it down here, and you can see it just shows that it read 4 records. So that the scan is essentially just doing a count, right, of the number of records in that case. Since we don't have our file saved right now, I'll just kind of instruct you through how this works. But the source function is instructing R to read the text file and execute its contents. So basically, what you have up here, this is technically a text file. I mean, it's a .r file, but you can read it via like Notepad or something. And so the source file is saying, okay, so I called my script.r, or I called mine test1.r, right? And so if I wanted to run that, especially if you're like trying to run that on like an AWS server, or you go to the command line or terminal and try to run that, that would be the best way. Now, the cool piece is that this function has something called echo. And if you set echo to true, so say it was this entire script here, if I didn't include echo, it wouldn't print all of this out. It would just print whatever the results are. So these ones that we see and whatnot, that's what it would show. What the echo does is it will print up all of this as well to let you know what's actually running. So it's a good feature to know and have. If you don't know that, though, or don't remember, we can do, can't remember if sources in base. I think it's in base, so that should run, right? Okay, yep, sources in base. So single question mark works. It reads R code from a file or connection. And look at all these other parameters you can do. So we just told you about one, which is just this echo. But there's all of these other parameters you can include as well. And you can see here, echo is a logical function, which means it's just true or false. If true, each expression is going to be printed after parsing before evaluation. So it's going to print all of this before parsing it apart and running each section of this piece. So it's pretty cool. You could do the same. You could limit it with this print eval, blah, blah, blah. But again, there's so many functions within R that there's no way that you should necessarily try to memorize all of them. The more that you operate in this space, the more that you go, oh, okay, well, the C function and 1:5 means I'm concatenating the integers 1 through 5 into a vector. Like, that's something that I know how to do because it happens often enough. But something like source with echo, it doesn't happen as frequently, right? You're saving those files and running them as batch scripts a lot less. So don't necessarily worry about memorizing all of the functions and features in here as long as they make sense to you and what we're doing. And then the same thing, you could do a command line batch script. So if you had a set of codes that you wanted to run in some sort of sequential order, you can do that. And all these can run directly from the command line. It's relatively rare unless you're at an organization that, like the Hadoop interface, doesn't interface with RStudio or RStudio Server. And so you need to run these batch scripts here and access RStudio somewhere offsite. So this will be less common in the real world, but when you productionize, and I say that because when you productionize in the real world, a lot of your R script may end up going to a data engineer, and you'll say, oh, okay, these are the 20 features we need to focus on. This is the model. And they may actually recode that in Java or something that's more optimal for a productionized environment. So a lot of times you won't end up having these batch scripts that you're running all the time. Are still used in production, but if organizations are looking to optimize speed, the majority of our packages run on like C and C++, so they are really fast. But there are some things that take a lot longer that would be faster in something like Java, C#, whatnot. So it'll kind of just depend on the organization you work with if you need to worry about any sort of batch scripting or running these source files. Okay, I think, yep. All right, so we're going through this fast. Okay. Actually, I guess before we get into this, since it's 5 minutes from our normal break, let's go ahead and take 15 minutes. I'll, sit around here, answer any questions you guys have during that time. But basically, all we're going to have is going through these sets of functions. So we'll play around with this a little bit. And then a little bit of data structures. We're actually just going into vectors today. So there's not too much more. Again, I sometimes talk fast, so I'm happy to go back through anything. I'm happy to stay here and talk with you guys with any questions you have as well, even after the course for today ends. But let's go ahead. We'll come back at 10 minutes past the hour, or if you don't have daylight savings, I think that's 40 minutes past the hour. And so basically about 15 minutes now. And then we'll go through these lists of about 20 functions, have a quiz, go through vectors, and then I will stay for any questions that you guys have as well. So I'll be here for any questions now, but otherwise go ahead and take a 15-minute break, and then we'll come back. So, and it might be dependent on where the location is saved. Let's clear that window. So we want to do source, and then I name my script test1R. Equal to true. Let's see if that runs. Oh, okay. Let's take that line out. Okay, let's save that again. And that's another piece for you guys to know as well. If you do type something into the command line or the console to play around with it, and you decide that it's actually important, you can kind of scroll up and using the up and down arrows to scroll back through recent syntax things you did. And so if I wanted to copy this, come paste it here as well. Let's see. So we have some error messages here. So we're going to these, save this, and then now let's see if this runs. Okay. Oh, I don't need. Okay, cancel that. Cancel. Yeah, sorry. I have a lot of things in here, right? Let's see. So we don't want to install this package again. Anything else? We don't want to install that package again. Let's see. Okay, so that should be good now, right? Okay, so we're doing source running test1.r echo equals true. So what it should do is print all of this and run all of this. So if we run that, here you go. It's printing all of these functions. And I'm still getting that. Oh, that's because I made it a vector. Okay. Oops. Okay, there we go. So that's what you're seeing there, right? It's printing all of the actual functions. So it originally printed just the syntax, which is all of this here. You can see the switch color. And here, you know, it's not actually running the calculations on those, but then here, you know, we have these vectors, so it's running all of those. So echo true just runs all the code is doing. Yeah, so if we don't include echo, so if we set echo to false, then you see it's just printing out the results themselves. So you don't necessarily know what the syntax is according to, it's just printing out whatever the results were for those things. Yeah, so it's essentially like if you, the real world case would be, you know, say you built a model to cluster your customer base, that you could just go in and say, like, I don't need to run these 800 different tests to know that I know the model is this, and so I just can run this script right here, which might just be like, you know, the 6 lines of code for running that model to cluster the individuals in your customer base. All right, cool. So we'll do this 2 ways. The first is we'll generate a little sequence to play around with, and then I pulled up something that you guys can play around with after we get through the rest of the course material. I'll walk you quickly through it. It's this diamonds data set, pretty commonly used. So close these up for a second here. So what we're going to do is, okay. And one of the interesting things that you can see here is that I can open up a new R script. It'll be clean, but the console still exists. What values you have, those all still exist, right? So if you want to keep different things in different R syntax files, that's perfectly fine. You want everything together, that's fine too. So let's name a vector vect1 and call it C1, 2, 3, 4, 5. So if we run that, we want to print that to verify it, 1 through 5. And so what this is basically saying is we decided to name a vector. You can call it a list, but I'd call it a vector in this case. And we're concatenating integers 1, 2, 3, 4, and 5, right? So if we didn't know how the append function worked, what is something we could do to figure out what would potentially be included in this parentheses? How do you guys figure that out? So I'll give you guys a second to respond there. But yeah, so if we don't know what to do for append, what ways could we go about looking at it to know what we could include in this help file here? Okay, so help append and question mark append, right? All right, so we run that. So this is the append argument. This should produce the same thing, right? Okay. And so it looks like here, the append has essentially the main aspect and then the filters on top of that. So the vector to be modified, right? So maybe we want to modify our current vector. So append vec1, right? And what values might we want to include? Well, maybe we just want to add 6 on top of there, right? So then if we go ahead and run this, oh, we actually have to do an assignment here. Okay, so so we essentially want to add the number 6 to vec1. And so the way this will work is we're using the append function on vec1, so that vector we had, which is this up here, concatenating 1 through 5, adding 6 on top. And then we're calling that vec1. Now we could call this, you know, vec2 if we wanted to, right? So we'll call this vec2 just to show you what exists in here. So we run this, now vec2's in here is numbers 1 through 6, not numbers 1 through 5. Now if I called this vec1 and I ran this, you can watch right here on this row, now it's 1 through 6, right? So depending on how you label this, because if I just ran this append 1 through 6, it's there, but then how would I access that? So I can't just, if I printed, or let me rerun this here, right? So vec1, 1 through 5, right? And if I ran this, append vec1, 6, and then ran this, it's back down to 1 through 5. So what we have to do is assign it to some sort of vector. Okay, cool. So we'll leave vec1 as 1 through 5. Vec2 is now that append on 6, right? Now let's also do let's do vector 3. And here we're going to concatenate, and then I'm going to give you that shortcut. So let's make it fun, right? Let's do 1 through 100. So this is saying, give me all the integers 1 through 100 and assign it to vector 3. And so we run that, and now it's an integer with vector numbers 1 through 100, right? If we wanted to print that out, we could do that here. You see the numbers 1 through 100, right? It's a very cool, very easy function. Identical, I've probably never used before. So, you know, I've been doing data science for 10 years. So there's always new things to learn. So don't be overwhelmed if you don't know. And so I go in here to the helper, do identical. Okay, it's in base. And it can return true or false, and only if it's exactly true. So what we might have is any R objects. So let's see if instead of just scalars, if it works with vectors, right? So let's go ahead and say we want to compare vec1 and vec2, right? Because we know one's 1 through 5 and one's 1 through 6. I don't actually know if this will work or if it only works for scalars. False. So it works with vectors as well. It should work with matrices and data tables as well. And what it's doing is just comparing the entire structure of this. And, you know, it could be as inane as one's numeric and one's integer, and it might show up as false. You could have this as a character string instead of numeric here. And even though, and actually that would be an interesting one to see, right, is if vec on mine, because that shows as int, and vec1 as num, which is 1 through 5, if those will register as true or false, or if it's just the character classes themselves, or what's within the string. False. And that's because the numbers are the same, but the character class is different. If I want to append 3 values in one shot, not necessarily in sequence. You know, so like, yeah, Puneet, you know, I sometimes I don't know, right? Because I'm generally working with very large data sets and I'm not actually appending because it's done on the ETL extraction process generally. We can see if this works. Unused argument. Okay. So can we append more than one feature at a time? Because it does say values, so it's likely that this needs to maybe be within another set of parents. We'll see if that works. And that still doesn't work. Maybe it doesn't include the commas. We could see if that. Unexpected numeric constant. Yeah, so that's something I can research because I was trying to, I know that you could do this functionality, but I didn't know if you could do disparate numbers like you're talking about. So I will write a note for myself as well for our next class because I'll end up Googling around to see if there's a way to do that. One of the ways you can be the most effective data scientist is if you get really proficient at Googling, because what people are going to do is assume you know how to do everything. So no matter what the space is, anything related to data, data cleaning, data merging, data munging, data modeling, and productionizing, there's the assumption that data scientists can do all that. And, you know, you can see just from, you know, day 2 of this course, there's a ton of functions and you may never have used them before. And that's perfectly fine. So a lot of that piece ends up being Googling around to find the right answers. So, you know, what I may end up doing is going in and saying append function in R, unique numbers or something like that. And it may take a little bit of work to try to find some sort of append that works. Because there's pi, there's after 5. Yeah, so it might just be, you know, for this case, and again, I'll end up looking around a little bit because I want to find out, but it might be that you have to do multiple appends, right? So you might not be able to do it necessarily within that single append function itself. And that's okay too. Okay, so identical, we've tested. We understand that it tests essentially whether it's a scalar, a vector, a matrix, whether 2 are exactly the same in class and what they contain. So let's use vec3 for the next few, right? So if we want to return the length of the R object, vec3, we could go here, vec3. There's a command 2 for selecting the most recent line, and I just forgot what it is. So we know, especially because it's an integer, that vec3 has 100 numbers in it. And when we test the length, we see that it has 100 produced as the output. Might not be as useful for something that's an integer or numeric that's so easy to look at and just have a count. But, you know, say you had a list of character strings, this would be a really nice way to get a count of how many are in there. The next function that ends up being really useful, you may end up using it pretty often, is list, shown as ls. And so if we wanted to go ahead and run that, we'll see I have age, color, GC torture. I don't even remember running that variable. Val, vec1, vec2, vec3, and x. And so just like you can see it here in my global environment, you could do that via a list. So whatever way is easier for you to look at it is one of the, I guess, best mechanisms. But that's why RStudio is a useful tool, because you can see those snapshots right there. If you are working in R itself, the only way you could see the variables is using this ls function. So this here says that range returns the minimum and maximum of the vector. So if we're running vec3, what numbers is going to be printed out, are going to be printed out? Okay. So just like you guys said, boom, right there, 1 to 100. And so we'll get into some of the summary type statistics and whatnot a little bit later in the class. And you guys will see like ways of looking at that data. But if there are things you need to look at, just like for this, right? So if we thought, let's say this was a questionnaire and people could only answer on, 1 to 100, but when I typed range, this showed up as 1 million as the largest number, then we know there's something erroneous with the data. And so there's a lot of things that we do for data validation and checks before we even really start working with the data. So we need to know, what each set of things in a vector, what variables in a vector or a matrix should entail, and then we can sort of validate against those to make sure they're accurate. That's why 60 to 80% of a data scientist's time is supposedly spent with the data cleaning and exploration process. Okay, so one of the cool ones, functions, are these rep and sequence features. Rep is just repeat. So if we wanted to repeat the number X n times, so let's say we wanted 5 10 times, right? And we could run that, you see the number 5 constantly repeating. That's an easy way to create like an identity matrix or something in that regard. Now, if we wanted to be able to access this later, then we need to assign that to a variable name. So we would call that vec4, run that, and then if we want to access that later, we can just type vec4 and then boom, there's those 5s. And that's how we can end up using it to, if we wanted to compare vec1 to vec4, we have to have those variable assignments there. Interesting. Rev function, right? So we go ahead and run rev. It says it provides a reverse function of its argument. So if a vector is sorted in a particular way, now when we get into the apply functions, there's better sorting mechanisms. But if you wanted to sort 1 through 10 from 10 through 1, instead of so if we have vec5, instead it's 1 through 10. Print that out. We see it's 1 through 10. Instead of reassigning vec5 to be, a concatenation of 10 through 1, we could instead do this reverse function, right, which would be vec5. So here, we'll run this, and now we print vec5, and now it's in reverse order. So not always necessary in regards to the data science aspect, but it can be useful in regards to pairing up different vectors together. Let's see, the sequence function is also really great, right? So let's say we did, so we don't have to reverse the data in vector 5. That there's not always necessarily utility for it, which is why I said interesting, because I don't use the reverse function either. Because as a data scientist, it's really about cleaning and understanding the data, which means you're looking at a lot of the structure and the summary statistics, doing correlation and scatter plots to understand what the data relationships look like as well, and distributions. So generally, you're working in a matrix as a data scientist, or a data frame, a data table. They're all pretty synonymous. So it's kind of just like an Excel file would be. So you're generally not needing to reverse something like this. But if for some reason you did need to reverse some sort of list, then this is one of the easier ways to do it. Generally, what you're going to do is some sort of apply function, which, you say, well, it wouldn't be a vector, right? It'd be a matrix and then, sort by age or something like that. And so that's what you would more commonly see, and then you can kind of look at patterns within that. But if you need to necessarily alphabetize something or something in that regard, then the reverse function could be useful. So in regards to the, don't worry about sapply right now, in regards to the sequence function, right? So it says it generates a regular sequence from x to y spaced by n. So let's say I put these three numbers in. What would you guys expect the output to be? Okay, got a few answers. Let's go ahead and run and see, right? All right. So you see the numbers down here, right? 1, 1.1, 1.2, all the way through 2. So what is sequence doing? It's saying, let's take all numbers between 1 and 2, inclusive, right? It includes 1 and 2. And let's take it by a step of 0.1, which means let's add 0.1 to 1 until it reaches 2. Does that make sense to you guys? So, and the reason this is really useful, if we're not doing random sequence, right? So let's say we wanted to create a, let's call it vector 6, right? And we wanted to create a vector, but 1 through 10 isn't, we don't want it, we just want the evens. So let's say we want 1 through 100, but only the evens. Then we'd say the min and the max, that 1 through 100 inclusively, by 2s. And so we go ahead and type that up, print the output of x6. Oh, and sorry, because I did it by 2s but started at 1, it's going to do all the odds in that space. I could have started at 2, run that, print that, and now you have it by 2s. So yeah, Usha, it just depends on if you're creating some sort of vector or matrix addition, and you need some sort of interesting sequence like this, because it's imagine that it's 1 to imagine that it's 1 to 100, a million by 7s. So for whatever reason, your boss says, hey, I need you to compile a list, and maybe he expects you to do it in Excel, of all the number sequences, and maybe we'll just start at 7, right? And so if we try to run this may actually take a second, or it's really quick. Okay. So then if I went to print vec6, and you'll actually get a max print because I'm printing a million, but these are all those numbers by 7s. So he would have that list. So it really just depends on what you're doing. It's kind of more of a data engineering or manipulation type thing, but it is a useful tool. And then unique is pretty commonly used, and that's because you're looking to remove duplicate entries from the vector. So let's say we have another vector, vector 7, right? And we say it's 1, 2, 2, 3, 4, 5, 6, 8, 8, 8, and 10. So we go ahead and run this as is. Oops, what did I do? Oh, concatenate, sorry. Okay, so we concatenate that. We verify the vector contains the right numbers. Perfect. Okay, so now our boss tells us that she wants only the unique numbers in that one. So we go, okay, we can do that. So we'll call it vec7 again, but this time we want the unique from the original vec7. And we run that. Now I print vec7 again, and it's only the unique numbers. So that can be really, really useful. It should work for character strings as well. So if you wanted to create like categorical variables, say we had the colors like blue, red, and green, then but instead of just 3, you know, there's 100 different colors. Then we could get all the unique factors, all the unique variables, and then do like counts by those or something. Everybody good on this page? Okay, great, great. So, second one, right before the quiz. Okay, we have a couple more things we can do. I'll open up a new one. New R script, right? So again, all this is still in my global environment, still have all these different vectors. So let's say, let's call it color, right? And we have color as green, all caps. Okay, VLOOKUP functionality in Excel. Yeah, there's something called crosstabs and cross tables, as well as some of the summary statistics that can do a lot of what VLOOKUP does, and tends to be a lot faster too. So, I mean, there's less of the dragging and dropping, but you can look at things spliced apart. And again, you know, like I say, you know, the biggest thing is that we're able to Google. And I probably do this every single day, right? So VLOOKUP in R, great idea. That would be great. Okay, Stack Overflow, one of the most common used resources in regards to this. So data set was too large for Excel. They have a categorical variable they like to assign to a number. So with the VLOOKUP, they would just do this. Okay, over here, they're talking about reading the table. So you're reading that file in. You're saying these text house types, blah, blah, blah. And then you can create this lookup table. So you have these unique functions. This is actually a lot more complex than it needs to be. But essentially, there's a lot of ways of doing those VLOOKUPs. So look, R for Excel users, right? So you could go into here, and then that's the concatenation on top of that. The header command we'll get into. These are the joins, merges, blah, 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 blah. Anyhow, so there's tons of information out there, and you know, this course and myself will continue to be a resource, but pretty much anything you can do in any other tool, you can end up doing in R. You just have to read through different websites to see. So you see here, like the merge command ends up being really useful, and you can have the by parameter used for any sort of sorting mechanisms and clustering that you need. Okay, so color green. And again, I should use the arrow indicator to do that assignment. Okay, so we assign color to green. We always want to validate. Boom, it's there. That's great, right? So what we'd want to do, maybe we'll end up wanting, so we have all these comments from people, but some people write in all caps, some people write in normal sentence format, some people write in all lowercase, some people write capitalizing the first letter of every word. And so what we might want is a common theme. And so, you know, this could be done for a vector as well. So what we might want to do is, so in this case, let's just call this color 1. And we want to lowercase the entire vector, even though it's only a scalar here, lowercase this variable. So anything that's in variable color, which means to lowercase green, we'll do that, right? And then if we print color 1, now we see that it's lowercase. We could do the reverse too. So color 2 to upper, color 1, right? We run that, color 2, now it's capital. So, I mean, the primary purpose this is used is, again, maybe you have a vector and you want to ensure that you can group accordingly because you want to have counts of the number of people who wrote the specific colors, but R is seeing green and green and green and green as all different. And so, you know, and there's other ways of doing this as well, because we can end up stripping white space. We can, but you know, the ideal is that we go ahead and we have to put quotations around all these, but we'd want all of these to lower. And then if we did counts, unique counts, we would get 4 greens instead of 1 of each of these types of greens. That's the important purpose for this. I loathe regular expressions. If you're good at them, I commend you. But they are really useful. I've used it like with Merck Pharmaceutical and other clients. And the way that it works is essentially grep and all of these different functions are regular expressions. And so what you look for are argument patterns. You can use sub and gsub. And it's probably best that I just go to a real world example here. So you can see what this kind of looks like. So yeah, so regular expressions, if you've never used them, I'm trying to find one that's actually good for you guys. Okay, yeah, it'll contain, let me zoom in for you. So what you might have is, let's say you have a matrix and one of the variables, so one of the columns, has some character strings in it, and you want to extract it, right? So maybe you watch cricket, and you know it's and this variable column will say like person 1, you know, scored, person 2 struck out, blah blah blah, right? And so you want to parse apart this first piece. So that's where grep becomes really useful. That's where regex is useful. You can extract basically anything out of a character string. And so, you know, if you want to only extract uppercase or lowercase, if you have, you know, spaces that you want to be ignored or not ignored. So what you might do for that player 1, because there's a space after it, is, you know, you might be extracting them //s, which means like I want to extract all that's before this space, and then we could end up assigning that to you know, a new variable. So, and the way we'd end up doing this, I'm getting a little ahead of myself. Just excited to show you guys, but you know, let's say our data table was called cricket, right? So we had loaded that. So then we would want to create, we didn't have the players' names in there, so we're extracting it from the text, and so we call the new variable player. And then we're running that grep function, you know, pulling from the text feature and then running all of this. So it's really, really useful. Regex is a little bit harder to learn. It's no one I know like loves it. It's not necessarily easy to learn. But, and I'll type these two in here for you. If you want to play around with regex, these 2 tutorials are pretty good. So a lot of data scientists don't necessarily know how to do that, you know, and again, like you can see, oh, look at all that. That's really confusing. It's not necessarily easy or intuitive, but it's really, really strong and useful once you become effective with regex. We won't really touch it too much in this course for anyone concerned. Okay, cool. So here's what we're going to do. Where did I open? Okay. So what I want everyone to do, and actually we'll kind of expedite this. I'm going to put this all in here, and then I'll copy and paste it into chat for you guys, because I want us all to work from the same space. Okay. Let's make sure everything's still running on here. Okay, perfect. All right. So if you could run these 3 lines of code, install.packages ggplot2, library ggplot2, and data diamonds. And then let me know once yours looks like this, where the data diamonds looks like it ran, no error messages, and then we'll move forward. Thanks, Manish. Yeah, so I'll tell you about the diamonds data set in a second. What it means is masking occurs if sometimes there's multiple functions. So sometimes they've been loaded, or sometimes they have issues. So margin may, the margin function itself may have some issue with another package that's currently loaded. So the way that R handles that is it essentially doesn't load that specific function. And that way you won't have any random errors pop up. Did not load. And you guys ran the install and the library and loaded the library ggplot2? Those 3 lines? Huh, interesting. Did not load. Did you get some sort of error message, Scott? Library ggplot2. Spawn up packages. Let's see. Successfully unpacked. Okay. Warnings are okay. Scott, did you do the install.packages ggplot2 as well? I know you said you did, but it should load if you've ran that line. And sometimes, you know, the best solution for you guys is if there's tons of error messages popping up and whatnot, not just warnings, but issues that can every now and then be quirky, you can just close out of RStudio. You can save the R data and then can open and load it back up. The reason I'm having you guys do this is because after the course, if you want, you can play around with it. Ran one by one, okay. Because I mean, you can see I got warning messages as well, margin, the R version built under ggplot2. But yeah, if you guys can at least run the install.packages ggplot2, and that works, then the others should work. If this line isn't working, then we have an issue. Yeah, Rahul, I'll go to in a second. It's one of the most common data sets. The other 2 that, you know, if you like looking at blogs or tutorials to supplement what you're learning here, the Diamonds data set is extremely popular, the Iris data set, and the Titanic data set. So all 3 of those have really clean data and are used in a lot of blogs. So if you like practicing, then that's one way to handle it. Yeah, that just means that, yep, yeah, it's loaded. It just means that because every time there's every single package can update whenever they want. That's just showing all the updates they do. ggplot2 is one of the most updated because it's all of the visualization tools, and they're constantly improving it. But within it, the ggplot2 itself, they actually have a data set called diamonds that's loaded in there. So the way to check that all this is done and working is view with a capital V and then diamonds. And what that should do is produce a data table, a data frame. So let me know if you guys got that to appear. Prasad, I mean, you should get something like this in regards to loading the library, but then if you run the view diamonds, you should get something like this. Oh, yeah, Scott. So, yeah, what you may end up needing to do, I think it's in global options. Packages. Is that right? Might be in our general. Where is it? Yeah, Scott, there's something in there. We can play around with it after we finish going through this little bit, but there should be a way that you can save it so it won't just necessarily save to the app data folder. You can specify where those save. Because yeah, I mean, we're not going too into details. We're not like building any models or anything. So, and I can always share the syntax too. Okay. So no output. Prasad, what do you mean? Yeah, that function is case sensitive. Lowercase view won't work. Yeah, so pretty much all functions are lowercase. For some reason, view is not. Okay.
Oh?
Yep.
Yeah, I make actually when I run I'm able to install the package, but after that when I run the couple of commands, library and data, I'm not getting any output actually.
So library and data might not produce any output because library won't produce any output other than maybe attaching package because these are warnings. So you might not do anything. And data doesn't produce anything. That's why I wanted you to run this view diamonds to see if you get this output up here.
No, I ran it both the commands. That I understand library attaches it, and then data when you run data and diamonds. What is the expected result of that when you run the command?
Nothing. All it's doing is loading data into the global environment. All it's doing is loading the data into the global environment.
Okay.
Are you good there?
Yeah.
Okay, perfect. Okay, cool. So what we're going to do now, so our diamonds data set's loaded, right? And I'll copy and paste what I type in here as well for you guys at the end, since I know a handful of you might have issues. So now this is a data set, right? This is what we're generally going to work with as data scientists. And there's certain things that we're going to want to do here. So we want to look at the summary of diamonds. So if we run this, now we can see that we get each of the variable names that we have. So if we looked at the data set, caret, cut, color, clarity, etc. So everything that's at the top, we get each of those. And then it's inspecting whether that's numeric, an integer, a character class, a factor variable, and it's going, okay, so this is numeric, so we're going to give the minimum, the maximum, the first and third quartiles, the mean and the median. Cut, it's going, okay, well, these are factor variables, right? There's 5 different factors: fair, good, very good, premium, and ideal. And these are the number within cut that fall into each of those categories. So summary is a way to kind of get a glimpse of what this is, right? And so, you know, if we saw the price, the minimum is 326, but if this maximum, say it was, you know, 100 million, well, that's very unlikely that there's a diamond that's selling for $100 million. So then we could go in and inspect and try to figure out what the heck's going on there. You know, we'd expect these distributions to kind of be similar in regards to clarity. So if there was, you know, a clarity that was, there were only 2 cases, and then another that had 30,000 cases, then there might be some issue with the data. So this is one of the ways that we go in and initially inspect this data. The other really fun way to do that for this data set is structure, STR. So when we run structure, what we get is a really cool summary type statistic, right? So we're looking at this data, and there's a couple things it tells us. It tells us we have a data frame, tells us there are 53,940 cases, and there's 10 variables. And then this is basically the header. This is the first set of variables, right? These numbers at the end. But the cool piece is that for each variable, it also tells you the class. So caret, it's saying it's a number. Cut, it's saying it's an ordered factor. 5 levels in a meaningful order. You can have factor variables that don't have some sort of order, say like colors, right? So if we had green, red, and blue, there's no order to those, so they don't need to be specified as ordered variables. But for these, we know that like color increases, right? So we want that to be ordered variables. We can look at the depth, numeric, numeric, integer on price, numeric, numeric, numeric. And so this is one of those things where if you know that like the price is supposed to be an integer and it shows as a factor or a character, then that's a problem. So this is another way for us to inspect the data to make sure everything's working appropriately. Compact, okay. Glimpse I very rarely use, and I don't think it'll run right now. I think I have to load dplyr. So I won't make you guys do this, but we can just see what it looks like. Okay, so what I'm going to do real quick, dplyr is essentially a cleaning package. So it's a great way for data munging, data wrangling. And we're going to see what Glimpse ends up looking like with it. Because I just normally use summary and structure, view, and a few other ones. But so we load library. It's loading it. And dplyr, I think we'll end up using next Saturday as well. All right. Taking longer than normal. Hope everything's okay there. All right. Is the data getting picked from package? I mean, that's why we had to load ggplot2. The Diamonds data set is hosted in ggplot2. Otherwise, I might have to have you do like a read CSV and all this other stuff. Okay. So dplyr actually took a while to install. That's okay. It's masking these other things. That's okay. It's optimized for version 3.3.2. So we'll try Glimpse, see how that runs. All right. So Glimpse works relatively the same, a little bit cleaner, right? So it counted the number of observations, number of variables. And then if it's a double, which is basically numeric, an integer, or ordered variable. So we have all these options as well. Let's see. So we can go ahead and do the class of the object. So I tend to just use the structure and summary, but you know, if you wanted to load dplyr or get a glimpse, you like this better, that's perfectly fine as well. Class, you're not worrying about too much, but it shows you essentially what's hosted within Diamond. We don't necessarily see all of these. We're only seeing one of them. The mode. Mode of diamonds. I don't use mode, so we can see what else it entails. It says that the diamonds is a list, but we want to verify and see what else it could be. So mode of that, you can get or set the type of storage mode of an object. So how can you do that? Well, you can do an as.new mode, and it could be, you know, as logical, as integer, blah, blah, blah. So those are much more common. Using the mode function, not so much. But if you had a, you know, if one of your vectors, so let's say we ran the structure again, and we see here that price is an integer. Well, what we could technically do, if it's supposed to be a character string, or we want it to be for some reason, is, you know, we could do as character diamonds $price, and then it will convert the price variable in the diamonds data set to a character string. And so you can do this to convert things to logical, to numeric, and a lot of times to analyze data, you have to do that. R can be quirky in that regard. So if something isn't running, then you might want to go and check the structure. So yeah, if price had actually shown up as a character string, and we know it needs to be, you know, an integer, you could do as integer, you could do as numeric, and now it can actually be used in some models. Character strings can often not be used in models unless they are converted to factor variables. So the mode function in there isn't useful in and of itself, but to know that mode allows you to as blank whatever conversion you want to do, that's really, really useful. I mean, I always use double quotes. I didn't mean to use single. I'm trying to remember. I don't think there's a difference, single versus double quotes in R. I believe there's no differences within R. It's just that double quotes is the standard. And we'll verify single and double quotes. Character constants used interchangeably, double quotes are preferred. So yeah, generally speaking, just always use double, but you can use either. Okay, and then summary, I guess I already ran that before, but summary is really, really great to look at the distribution of the data and make sure everything's accurate. Okay, let's minimize this. Hide this. Now, quiz time. Cool. So, this is kind of what we were talking about before. I didn't have a good example for you guys. So I will see how you guys answer it, and then I'll walk you through these in regards to what they do, right? So, which of the following is a valid equation? True percent divided by percent false equals true. True, and mind you, this is an OR operator, right? So true or false and false not equal to true is equal to true. True or false and false not equal to true is equal to false, or A and A. So I'll let you guys try to answer, and then I'll walk you through these to let you know what each one is basically asking. So these are really just and or not operators. You're likely not going to be using these in the real world too much, but it is important to understand it from a logical perspective. Because you may end up doing these in like a for statement. Okay, B. Okay. All right. Yeah, most people answered. Okay. So what is this saying? Well, this is essentially a remainder operation. It's mathematical notation, so you can't do it. So true with the remainder of false, like, or what would the remainder be if true divided by false? There wouldn't be one. So it doesn't make sense. This is saying we have to look at this in a couple different ways, right? And pull this up. Okay. Let's highlight and let's make this a little bit smaller. Okay. So this operates as true or false, right? So either one of those options, and false is not equal to true. So this is another operator. This is another set of operators. You see the parentheses, so they operate in a different space. So this is saying that this could be true or false, and this is saying that we need to verify that false is not equal to true. Well, that's true, right? False is not equal to true. So this produces a true statement. And then this is true or false, so it could be either true or false and true. So it hits true and true, so it is equal to true. You know, this one is saying essentially the opposite, right? So if this had been true and false, well, it can't be true and false, so it would be false. False and true would produce a false. But because this is the same operation, this is wrong because it's true. And then, you know, character strings are case sensitive. So A is not equal to A. And I think we're good there. All right, let's clear that. Cool. All right. So what would be the correct operator to fit in the blank for 4 blank 3 equals 1? Is that 4 divided by 3, 4 times 3, 4 remainder 3, or none of the above? All right. See a ton of C's. Correct, guys. So yeah, it's basically the same. What's the remainder once you divide 4 by 3? So that's correct. What will the output of age assigned to 18, age assigned to age, print age? So what would you guys see if you ran that line of code? Okay. Looks like primarily A's and a couple of B's. So what we see is we're saying that we assigned age to 18, and then we also assigned 18 to age, which is the exact same thing, and then we printed age. So this ended up overwriting this first line, but age is still 18. So if we print age, then it should print 18. So all this would work because this overwrites this previous statement, and we're just printing this. Again, you know, generally speaking, you should never do these left assignment operators, but you know, in regards to R interpreting it, it can at least interpret it correctly. Error messages, quite common in R. You'll see and get frustrated, but that's perfectly okay. You will basically never see NAs, and you know, R isn't like C or something like that, so it never goes into binary. Okay. And you can go ahead and type this out yourself if you wanted to. But yeah, once you're assigning the variable age or 18 to the variable age and printing it, you're going to get the variable 18. Can an if statement be used without an else block? All right, you guys all answered that quick. Too smart for your own good. Yeah, so you don't necessarily have to have an else statement in there. That's pretty much all you need to know. It's, I mean, you're generally going to, because you generally won't create an if statement if it doesn't exist. But it is perfectly feasible, and R will run it. Okay, what would the output of num 1 through 5 for val and num next break print val be? Output will be an error. Output will be numbers 3, 4, 5. There's no output, infinite loop. Take your time, think it through. No rush. So you want to interpret each line of this code. All right, what do we get here? All right, I'll let a few more people answer as well. We only got 5 so far. Let's see, 1, 2, 3, 4, 5, 6, 7. See if we can get 2 or 3 more answers on here. I think we have 13 in here, or 12. So I guess technically we have 10. Okay. Okay. So output would be C. Now, why is that? Okay, well, what we're doing is we create a vector of numbers 1, 2, 3, 4, and 5. And it's saying for each value in number, we'll move to the next one, and then we break it, and then we print val. Because this break is right here, it doesn't print anything because we didn't ask it to print the evaluation before the break. So all it does is essentially move right to the break, and so nothing will end up printing out. That makes sense to you guys? If you move the break, then it would be different. If you move the break to after this, because you went to next first, it would start at 1, it would move to 2, 3, 4, 5. Okay. So you guys just learned a ton of information, right? There's 4 types of operators: arithmetic, relational, logical, and assignment. So arithmetic are the typical plus, minus, multiplication, etc. Relational, like and or. Logical, true, false. Assignment is labeling variables. There's 2 types of conditional statements in R. If else, nested if else. There's the if, elif, else as well. And that you can definitely do nested if else statements within R. There's 3 types of loops: the for loop, the while loop, which has limitations, and the repeat loop, which will go on until there's a break. If you wanted to run an R script, you can use that source function. You can use echo with it to see what the syntax is. If you had a batch of scripts you wanted to run, you could use the R command, batch command. Commonly used functions, we went through all of these. Again, you have access to these slides, so feel free. You could also go ahead and use any of these with that diamonds data set. So now that that's loaded, you can look at the range of some variable in there, which would mean you do diamonds, $, and the variable name. There's no character strings in there, so the lower and upper won't really work. You could do unique of any variable in there. Again, it's diamonds, $, the variable name, and you can get all the unique values. So all of these can be done. If you wanted to append, you can append to that data set. You're good. Sure, Usha. Okay. So I'll unmute you real quick, and then I'll answer any questions, and then we just have, I think, like 7 slides looking at vectors, and then I can let you guys go early, and I'll stay to answer any questions.
Hey, Matt, can you hear me?
I can.
Okay, yeah, perfect. So what I'm trying to do here is I'm looking at all these functions and everything that R is providing, and we do quite a bit of data, mining and sorting them and trying to understand how we can come up with the best modeling for the work that we do. So out of all these functions that you have, if I want to run a quick project, take best learning today and do this quick project on the data that we already have within the office, so what do you think are the most popular functions that we can do it with?
Yeah, so in regards to so we have the view, which produces the data, so you can kind of get a look at it and you can skim through it. Let me make this full size. So that's really nice, right? So just kind of get an understanding. You can sort in here. So it's a great little feature. And it's pretty fast for it being in R. You have 50,000 rows. You can still skim through all this quick. The summary and structure are really, really important. I use those all the time. And then there are two others that I didn't include. And I'll send a good link for each of these to you guys in here. But there's two, right? So this one here is a correlation matrix. And mind you, like, you don't have to, you know, use all these, memorize all these, anything like that. So this first link, correlation plot, looks at sets of relationships, the correlation between all variable types with all of the variable types. And so you can see here, this is the +1 to -1 correlation. Obviously, any variable is fully correlated with itself, but you can see, like, you know, miles per gallon is inversely correlated with the number of cylinders, right, or the numbers of the horsepower. So this one's really, really useful. I often use the numbers. I use this primarily to handle something called multi-collinearity. I think we'll get into that later. Essentially, multi-collinearity looks at data, and if you have two predictor variables that are really highly correlated, then their actual strength of impact on your outcome variable will be reduced. So basically, if you had something like dispersion with cylinders, you can see these colors are pretty similar, right? Or if we go to the numbers, 0.9 correlation between the two. I would only use one of those two in a model because their accuracy would be reduced if I included both. Okay. The correlation plot, really important to look at such relationships between predictors. And then scatter plot matrices are really, really nice. So when we get into visualization, scatter plots are fantastic, guys. And the reason we might do them is to get an understanding of the data within a variable. So like this, you know, you can see it's a strong linear equation. But if I look at scatter plot matrix, actually I should do it in R. So if I go to scatter plot matrix in R, and we'll go to like this one, even though it's a little bit smaller, we can see this one in the bottom corner. It looks like it has something called a curvilinear function, right?
Yes, yes.
Linear function is good, but the curvilinear means that we have to do a data transformation. So these
you
are
do an here on the correlation.
Yep. So yeah, I square the original variable to make sure that it then creates like a linear composite. So those are like the primary things I do in regards to the data investigation phase.
Okay, so one more question. So we do all this, correlation of scatter plots, everything is available in Excel as well. So we do that. How is it different in terms of doing the exact same work in Excel, though it is, you know, scalability is always a big question versus doing it in R. And you showed me one example where you can look at the data pretty fast, which is very important for us as well. Yeah,
so like, you know, with, like if you are in Excel, to do a scatter plot, you'd have to do it for every variable with every other variable.
Perfect,
But this scatter plot matrix, it's actually a function, right? So I can do, all I have to do is, where is it? Scatter plot matrix, here we go. So I could do pairs, and I can say, okay, I want you to look at the relationships between these four sets of variables in this data set. And so that single line of code produces this whole thing. So instead of you having to manually create 6 of these, you automatically created all those with one line of code.
Perfect. Yeah, makes sense. Okay. You answered all my questions, man. Thank you very much.
Okay, sure. Thank you. Okay. Let's see. How to accept input value from user in R. Rahul, what do you mean? And while you're responding to that, you can go back to the next function in here. I mean, I could take you off mute or something. Can you explain more in detail what you mean? I can't remember if you have a mic, though. And I mean, if you mean in regards to like a survey or something in that regard, you know, there's nothing that's there's no live stream in regards to R. Well, I'll let you type for a sec, and then I'll answer Manish's. So, Manish, you can see here, the next statement helps in skipping current iteration of a loop. So you might want to, and this is where like nested statements would end up working really effectively. So if you got to a point where if the value is equal to 3, then next, then you can skip, and then you could have another if statement that works like that. Kind of like break, but it would skip a specific value or specific something that you're trying to do. And then your other question, grep, yeah. So that's why I sent those regex things, grep and R examples. So let me see if there's maybe Vanderbilt's site. So yeah, like here's one example, right? So this here is saying gsub is another part of the grep package, and we're saying, okay, let's do a substitute. Let's find any place we see a $sign, let's replace it with a dot, right? And there's plenty of other ones too. So you have look at all these pattern matchings you can do. You can do string splits. So there's a ton you can do with it. It really depends on what string you have, what you're trying to do. I mean, I could share this link as well because it looks like it's pretty good in regards to the information there. Value parameter. Do you have something else you mean towards that? No, I don't know. Interesting. Do you have a link or something that you saw? I've never heard it used, that's what I'm asking. Unless you mean these pieces here, which is just a function, a filter function. Okay. Yeah. So yeah, you have something like that, then the easiest way is going ahead and doing that help function and then going in and seeing how it's defined. Because a lot of times filters and parameters, you don't necessarily know how it's defined. So you're saying the value filter. Okay, so we go down to value. If false, a vector containing, go away. If false, a vector containing the integer, if it's an integer, indices the matches determined by grep is returned, and if true, a vector containing the matching elements themselves is returned. So that means that, do you want the actual numbers themselves and those actual elements, or the row that the elements are in? Okay, cool. All right. So I will go through this next set, and then I'll post the poll, since we forgot to do that, or I forgot to do that during break. I apologize, which is just that one question survey. And then I'll stay on for any other questions, anything else you guys want to do or explore, but it'll let you guys get out of here early if you want to. So the last piece we have, again, we're not going through all of data structures today. We're just getting into vectors, which you guys basically know what the heck they are already. So different data structures, elements of different data structures, and acceptable formats to import and export data. So we'll get into these other pieces next weekend. But what we have here, essentially, there's vectors, matrices, arrays, and data frames. And then I guess technically you have lists too. They're not the same as Python list. So vectors are one-dimensional arrays, right? the best way to think about it is a single column. And so this one labeled vector A is concatenating this set of 7 numbers, or this set of 3 character strings, or this set of 6 logical operators. And there you go, right? It says numeric, character, and logical vectors. So all those are completely feasible. Within a vector themselves, they can only be a single class, whereas like lists could be multi-class. You can also have one element vectors. Again, those are called scalars, but they're essentially synonymous. It's just a 1-by-1 matrix, just like a vector is a n-by-1 vector. The colon operator, we've already gone through quite a few times. It just tries to make things more efficient and easier. So this 1:5 is the exact same thing as C 1, 2, 3, 4, 5. Seems arbitrary now, but if you're trying to put in, a million operators, you don't want to do that by hand. So that's where this comes in much more effectively. And that's where, if you needed to create a list or some sort of vector, that's where that sequence could come in handy as well. So you could sequence like 1 through 1,000,000 by 13, something like that. And then numeric vectors of positions within brackets is used to refer to various elements of a vector. And so what does that mean? Well, let's say we create this vector that concatenates the letters A through F. Vec with bracket 1 returns the first element of the vector. So if you built this out, right, and you concatenated A through F, labeled it vec. Vec 1 is going to return A. It returns the first item of the list. Like vec 2 would return B, right? You can also pull multiple things out. So you could do C2:4, and it would give you B, C, and D. You could do 2:4, and it'll give you B and D. So it's a way of using the essential index function to access the vector itself. The first one shouldn't produce anything because it's a concatenation. Unless it's just a shortcut that exists now. This should just produce an error, or it won't. Okay. I always suggest using the concatenate function because it can produce erroneous. In other cases, it can produce some erroneous things. This didn't used to run as a function itself, but it looks like it does now. So we'll get into arrays next Saturday. Yeah, there are just like some nuanced differences between a lot of this stuff in R. Something like Python or Java has that much more explicitly defined. In R, not always so. And you'll end up seeing things like there's data.table, data.frame, and there's a couple of things in regards to how these are done where they're basically, because pretty much all the data you work with is still a flat file, right? Number of rows by columns, and you're not working multi-dimensional in that space. But some of these, like a data table versus data frame, can process things faster. So there's some nuances that are just involved in the playing around with the data process. And that's why, like, us going through this next weekend will make things easier in regards to you knowing what you need to do so that it runs as efficiently as possible. And yep, okay. So that's where we'll stop for today. Real quick, before anyone asks any questions, let me go ahead and run this poll real quick for you guys. Might have to, let's see, polling. Okay. So let's open, and we're going to pull this from let's see, where do I have that? Downloads? Okay. So just one question. Please answer that just the next 2 or 3 minutes. I will hide that. So your answers are anonymous anyways. I don't know who says what, but just review for me to know if I need to slow it down, speed up, if you guys are getting everything. And then after you fill that out, if you have any questions, feel free to stay. I have 30 minutes to answer any questions you guys have. Otherwise, can let you go early, and I thank you for your time. And again, you'll get that Net Promoter Score as soon as you exit out of there. The 1 through 6 is a detractor, which means that you hate this course and hate me. 7 through 8 is a passive, which means you're not satisfied, and please let us know we're doing better. And then 9 and 10 are promoters. So that's what I'm aiming to be at based on both the course material and how I've taught. But please fill that out as feedback from me. Manish, so the recordings are listed in R. I know that Vishal could go back through it again. He went through it yesterday evening, but can show you exactly where to go to download those. Oh, the recordings I think take 24 to 48 hours to post. I'm sorry. Sure, Scott. And I can take you off mute if you want to, or you can just type it. Thanks, Jay. You too. I appreciate it. Yeah, Scott. And if you want to stay, I can give Vishal access to let you to go back through kind of what he went through yesterday, because I think we didn't have you here yesterday. Yep. So he could show you that in regards to where you can download the slides, the lectures, as well as the recordings for this course. So those recordings, as I was telling Manish, aren't posted for, I believe, 24 to 48 hours. So you'll be able to access that probably on Monday, if not today. But the rest, he can walk you through if you want to see where to access everything on the course. Thanks, Usha. Have a great day. Yeah, the slides are already on there. So you could go directly into R, and on the right-hand side, I believe, I just lost access because my my previous course expired. But what you should see, so I won't be able to fully get in here. That's why I said he can walk you through. But this data science with R, if you go into it, and then on this right-hand side, there should be a button up here that'll let you click, and you can end up downloading. Yep, Puneet, we made it through everything. So if you have questions or want to play around, I'm happy to stay on. Otherwise, I hope you have a great rest of your weekend. You too. Usha, it's not quite a data table. I mean, it's really just a vector, but because what you'll see is that the structures, vectors, matrices, arrays, data frames, and lists are all, I don't know, a cognitive component. But then there's different ways of reading data, which is like data.table, read.csv, data.frame. So there's a few different ways that the data can be assessed. And in regards to the calculations that are done, that can have an impact on performance. Okay, we keep going in order. Let's see. Individuals may be able to explain the functions, packages, how it will relate to real world. I'm still not able to link up. Yeah, Manish, I'm going to keep going through this, try to bring in real world examples and whatnot. But I think once, and that's why I brought the Diamonds data set up today. You know, it wasn't required for me to do, but I kind of wanted you to see what this looks like for a data scientist. So you may end up having hundreds of variables and millions of rows, but essentially what you're doing is you have this data structure. And now this is a clean data set, right? Everything's filled in, everything's nice. There aren't those issues with like integers and numeric or character strings, anything erroneous. So there's a nice like data set to play around with, look at the structure, you know, and I mean, like, there's nothing that's stopping you from saying, oh, I want to build a linear model, right? And let's see if I can do this off the top of my head. So I want to build a linear model, and I want to predict the price, that might make sense, based on the caret cut, color, and clarity, right? And that data set is diamond. So this should run, I hope. Okay. And then the results here. What is the best way to look at results? So I ran that, and I can see, you know, and we'll get into all this, but like, so this means these variables are significant. These are their coefficients, which means like, oh, okay, the carrot contributes almost $9,000 when building the model, and then cut, you know, looks like it could be plus or minus depending on the cut. You know, color takes an inverse hit on L, but is positive for 4. And so all this, and then you end up seeing like, okay, so those 4 items, carrot, cut, color, and clarity, predict price with essentially 92% accuracy. So that's how all this will end up relating. You don't have to worry about all this now. I'm just trying to help get you to understand R and kind of reading the syntax and being able to leverage it. But it's not necessary that you combine everything in your head yet. But this is kind of the work that you'll end up doing. So a lot of it's that data exploration process, and then you also have the model building. Thanks, Scott. Thanks for cool. Okay, so if we're looking at calling X, the concatenation of 2539811.6, and then we assign count as 0 for evaluation of X. Okay, so this is saying that we start at count 0 for each value in X. If the value, when you divide by 2, has a remainder of 0, then we'll add 1 to the count. And then we'll rerun it. And then we'll end up printing that, if that makes sense. Thank you, Raj. Manish, what do you mean by something from your site can be done? And then, yeah, I mean, we'll get into, you know, all this in regards to data modeling and analytics. This course, which questions, Usha? While you're responding to that, yeah, Manish. So, like, we went through this today. We're going to get into apply functions and deployer, which are a lot of the data cleaning. And then, you know, unit 4 is a lot of visualization. So, like, heat maps, really cool, right? Box plots, word clouds, blah, blah, blah. And then we start getting into the actual statistics, right? So looking at distribution types, looking at distance measures. And then we start getting into hypothesis testing itself. So A/B testing, t-test, z-test, and chi-squared, getting into all those, as well as ANOVAs, which are comparing multiple group differences. And then we actually get into the model building, like regression models, least square, nonlinear regressions, classifications, decision trees. So this is all sequential. We'll all, everything builds on each other. So that's why you're just learning the R framework right now. And then everything will build on that. So yeah, we'll do the data modeling, but we want to make sure that you understand the data structures first and how to visualize things, because it's part of the exploratory data process, data cleaning, because all that's done before the modeling. And then we'll actually get into hypothesis testing, which is the statistics, which is that cognitive framework, and then the actual data science modeling. Yeah, so if we go ahead and run this, right? So what it's doing is going through and says, okay, so if 2 is divisible by 2 equals 0, we'll move the count forward 1. So it should be 2 plus 3, right? Or 2 plus 1 is 3. Does that make sense? The statement essentially ends up stopping because the first one, it doesn't leave a remainder, the remainder is 0. So then we just say, okay, that number was 1, 2 plus 1 equals 3, and print 3. If it had been, because how this should work, if it's 5 first, then I totally think it should be 9. Oops. 2. 5 divided by 2, then the remainder of 1. Oh, 5 divided by 2 equals 2. What is it saying then? So this would run 5 first. 5 as well, 2 equals 0. Then why does it print something? No, it should loop through, then 3, then 8, 8 by 2. The 0 is not divided. It's here where that count is 0 plus 1. Oh, I see what it's doing. Okay, so I think the outcome will only be 2 or 3. Because yeah, the that count. Yeah, where was 0? Count was 0. So what is it printing then? I'm intrigued too. Because it's reassigning this, but we start at count equals 0, and then we say for value in x, so we'd start at 4. If 4 divided by 2 has a remainder of 0, then we would add count, which would be 0 plus 1, which would be 1. So then we would reiterate through. Now the count's 1. And we would say for value in 3, so for 3, if 3 divided by 2 equals 0, it's not, then it shouldn't do anything. Oh, okay, so that makes sense. So what it's doing is 4, 8, and 6. It loops through all these, right? Because there's no stop point. And so it loops through this whole string. And this is saying if it has a remainder of 0, then we'll add it to the count. And so the ones that will have a remainder of 0 are the even numbers. So it's counting 4, 8, and 6. And that's why, yeah, 2. Yep. So does that make sense? So the essential summary of this is that, yep, it's basically just doing a count of the evens. So this should just do a count of the odds. So if I'm not wrong, this should be 3 as well. Or we can add another one, it should be 4. Yep. So yeah, so essentially it's saying all we're doing is counting the number of even numbers. So as long as it doesn't have a remainder, then we'll add it to the count and start the new count number over. So like when you get to 6, when it's iterating through, so it's just for 6, if 6 divided by 2 doesn't have a remainder of 0, then we'd add that to the count. And it looks like we would already have a count of 4 and 8 also having that. So it would be 2 plus 1 equals 3. Yep. Sure. Yeah. So, I mean, sometimes you have to read through this and try to figure it out. Because, yeah, it took me a second to realize that the count was actually the built-in function count. Okay, great. Anybody else have any questions? Looks like a few people left. Thanks. Have a great week. Sure, Scott. Okay.
Can you hear me?
Yep, I can.
All right, excellent. Hey, had a couple questions for you. I actually figured out the issue where I could repoint my library, so that was good.
Awesome.
Had a question on actually a little bit. So you said you've been doing data science for 10 years?
Yeah, for way too long. I mean, it wasn't called data science back then.
Sure. So I'm actually approaching this I'm taking this class primarily, I'm planning on being I'm a platform admin.
Okay.
And I do have some programming background. I was curious if you knew of any, anything that might be, I definitely want to do this course. This is a fantastic course for me. But I'm also interested in like our server administration. Do you know of anything out there like that?
I haven't, but I got an idea. I mentor on Springboard. One of the cool things they have built in is a search function of courses all over the internet.
Okay.
So let's see. Our server web apps. Let's see. I know Shiny. I'm just wondering if it only does Shiny.
Is Shiny, can you describe Shiny? I'm not quite sure I understand what that actually provides.
Yeah, it's basically interactive.
Is it like Tableau?
Yeah, basically. So yeah, that you could live approach and people can use drag and drop and sliders to handle anything.
Okay, so it's like data visualization.
Yep.
Okay.
But yeah, if you're interested in our server, our studio might have, I'm trying to remember if they do or not, they might have training on it.
I couldn't find anything there. I actually asked them, and they sent me a PDF and said, here you go. But I thought, okay, that's maybe there's just not much to it. Have you ever used Revolution R? Or I know Microsoft bought them now.
Yeah, that was asked in my last course. I haven't. I mean, I followed them with what they've done, but I haven't used it. So,
okay.
I mean, I was looking. I was showing the class yesterday. I forgot. I don't want the blog. Oh, that's actually our server. Yeah, they actually have, interesting. Microsoft's really trying to take over the space.
Microsoft bought Revolution, and it's quite interesting because now they're running Linux servers.
Yeah, so yeah, if you can see this, yeah, they have all of this built in, so the diving into data analysis, and so there's some interesting things in here, like since someone was asking about pivot tables earlier, there's the cross tabs right there built in. So this also has a ton of stuff as well, but I haven't had time to actually use it to see how good it is.
Okay. All right. Well, if you come across anything, I'd appreciate.
Yeah, I'll leave a note. I guess I didn't write your background down yet. So let's see, what did I do before? So have you worked with big data science space at all?
Well, my background is I was an ETL developer for years, but I'm now more of a platform architect and admin. So I've done SaaS for years, Informatica, BI tools like Hyperion and stuff like that. So I've been in that realm, but I haven't really gotten into, this is kind of the first foray into big data, as far as I haven't really had a chance to mess around with Hadoop yet, some of the newer technologies.
Sure. Yeah, and I mean, it'll also depend on your organization, its needs and whatnot. I was showing people yesterday as well. So, yeah, depending on how large the data is, you can install, our server, but sometimes that does have issues.
Yep. Yeah, we've actually got installations of our server installed. It's more of it's a proof of concept that's kind of going into a production area. So we're going through that process. So that's something where it'll probably be turned over to my team to manage.
Okay. Yeah, and I mean, so yeah, I've been with organizations that have had our server. We sometimes or often implemented Apache Spark or H2O. The nice things about both of these is their big data processing. The nicer thing about both these is, it's not going to show it on here. Interesting.
So H2O runs on top of Hadoop?
So, yep, you can, I think you put on AWS too, but yeah, it basically runs on Hadoop. But the nice thing is that, Spark can run Java, Scala, Python, or R.
Right.
And then H2O also R, Python, Scala, Java, as well as JSON,
okay.
Tableau. So, these are nicer because they do handle big data processing in a Hadoop-like fashion, unlike our server, and you still get to use all the R syntax.
Right.
So that's an option as well. And then there are, courses on Spark and H2O.
Yep. Okay. All right. And as far as the, I wasn't able to attend last week. You said that would be posted later? Something I read in regards to our documentation said the videos are normally posted 24 to 48 hours after they're done, but then all the slides are already on there. Where would I find the slides? Would that be in the batches or somewhere else?
So the batches themselves is where you would download the videos. If you went into the, I was saying that I need to re-ask for live access, but for the R course, once you click on through here, and it should be on the right hand side, there should be an icon with 3 lines, and in there should be a download that leads to a zip file that has all of the PowerPoint slides.
Okay, hold on just a second.
I think that's right, if I recall.
Yeah, see my. Let's see.
But yeah, basically you should get this right side, something should kind of pop out, and then there should be an option to download a zip file.
Okay, I might have to ask somebody with Simplilearn, because I don't see that on mine, but that doesn't mean it's not.
And I don't know if our host is here. He works directly in regards to the management of loading and making sure everything's operating on the website. So, and that he's the one recording this as well. So he could also provide access there if you can't find it.
Okay. All right. Hey, appreciate it. Thank you.
Yeah. Thanks, Scott. Have a good day.
All right. You too.
And now, they should be posted on the batch setting that our host was showing yesterday, and but it'll take 24 to 48 hours for it to be posted and uploaded. So it probably won't be available today, but if you go on tomorrow, you should be able to get access and watch that. Sure. Thanks, you too.